Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, or you are amongst the 50% of the people who have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live. But most importantly, if you would like to join the debate with the page you are currently listening to me on muted, simply click the link in the info box below this video to join the discussion and express your views on the shape of the Earth. There are a couple of rules on the show. Number one, please do not swear. If you do, you'll be ejected. And if you are, please do not try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. In a moment, I'm going to transition across to my photos so I can share the show. And I would encourage anybody who is currently in the live audience to please also share the stream on social media. Sharing, very, very important as it increases the live audience, of course. Yes, it does. But that in turn increases the likelihood of us having a more diverse panel. So once again, please share the show. And one last time, if you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Oh, looks like we've been joined by our first guest. Let's raise the mic on the Hangout as we have been joined by...
It's your favourite Cat Earth.
How you doing, Alex? Good to have you here.
Yeah, I'm good. How are you?
Not too bad. And we've also been joined by Brenda. How you doing, Brenda?
I'm fine, thank you.
And Chris. How you doing, Chris? Good to see you.
Hello, mate.
Excellent. Well, I've got a few guests. I'll leave you guys to chat amongst yourselves.
I'm just going to get my chat pop out. Chat to pop out. There we go. Now I can bring up full screen. Good show.
I'm joined by Arwin and Ali B. Good to have you both here. How you doing, Arwin?
Hey, Nathan.
Very good, very good. How you doing, Ali?
Nathan.
I think he's doing a Lewis and streaming his chair.
Nathan.
Oh, yeah, nothing yet.
Yeah, Gareth. I get a lot of snow. Yeah, we get about 4 to 6 inches.
Try that again. See if we can hear you, Ali. Ah, there we go. Good to have you, Ali.
Did you get snow, Nathan?
Yes, lots.
Ali? Oh no, you're not in Scotland. Right enough.
No, I'm in Denmark and we've not had any snow yet at all, so still.
I heard the gritters last night about 4:30, 5 a.m. and but this morning, there was just no way I was getting out the street. There was just no chance. Front wheel drive, no way, wasn't happening.
Sorry about earlier today. I was pissed off at you, Nathan.
Yeah, me too. Still
Yeah.
am.
Don't have to apologise to me.
That's all right. If you behave yourself,
That was kind of
No,
fun.
no
I
need to
behave
apologise.
I'll forgive you. No, Nathan. You're
No
fine.
need to
with it,
apologise.
except for when you're deleting files.
Oh, I get pissed. I get pissed off.
No, don't blame you. I think people are very mean to you, actually, Brenda, in this flat.
They
I
are.
do agree on
Yeah.
that.
I'm used to it.
I know you'd have to get.
Yeah, some people are. I've seen some disgraceful comments towards you in the chat.
That just reflects poorly on them.
It does.
Certainly does. It
Nobody's
certainly
perfect.
Yeah, but you don't have to be mean, do you?
does. No.
So let's talk about the Isle of Man.
Yeah. No.
Everybody
This
loves
is
that.
good because we want to talk
Delicious.
about the lighthouse because we're talking about this 1,000-foot wall or whatever. But what we really want to talk about is why there's 138 feet missing from the bottom of the lighthouse that we've all been talking about.
Yeah, right enough. Because there shouldn't be anything missing
Ball, right?
whatsoever.
Because the Earth is a ball, that's why it's missing, is it? Because it's behind the curvature.
Well,
Of
why
course.
is it missing then? So this is what you've got to
Because there's a
answer.
big curvature there. That's what.
Oh, okay, but someone who believes the Earth's flat has to answer this.
Clever. You're so clever. Of course it is.
So someone who's okay, it's a good
It's not
answer.
about being clever, Ali.
It's a question.
Yes, it is.
If you think it's clever, what I figured out, then fair enough.
You're always playing the victim.
No, there's a roughly 138 feet missing, right, from the picture. Because we could bring the picture up and look at it again, because I can't quite remember it. But that's how high the lighthouse is above the water. I'm not trying to be clever. I think it's a reasonable question to ask if the Earth's flat.
Yeah,
Why is there 138 feet missing?
You wouldn't accept any answer, though. That's the thing.
Oh, no, well, come on, give me an answer. You haven't tried to give me one. You just
I've
moaning.
not even looked into it. I've got another thing. I'm debunking that idiot Soundly at the moment.
All right, well, then
Idiot.
someone else can answer.
Come on, that's unfair, Ali. That's really unfair, man.
Been joined by
Well,
Lewis
the
The guy's
Hackett. Good to have you
anything but
here.
an idiot. The guy is obviously
It's not my fault
competent.
I'm an idiot and
And-
Been
dishonest.
joined by the Rumpus as well. How you doing, the Rumpus? Good to have you.
Thanks.
Hey, Rumpus.
Hey.
Ali, that's really unfair to call Soundly.
No, it's not really because it's true.
Yes, it really, really, really is. The guy's obviously competent. He's intelligent. He knows what he's doing.
Yeah, he's intelligent. He's intelligent at hiding things.
Don't
Why?
let Ali
What?
obfuscate now. Let's talk about this 138 feet that is missing from the bottom of the lighthouse. Seriously. 138 feet missing from the bottom of this lighthouse.
Oh, God, where could it be?
Hey, where could it be, Ali?
Hey, could you? I have an answer for all this. Just go ahead and present me. Just Nathan, if you could just go ahead and just present me to everyone.
Oh, you've got something prepared?
Yeah,
Cool.
just present me.
Wow.
Oh, great. A demonstration.
I went down to the demonstration to get my fair share of abuse. Anyone know what that song, the lyrics from that is?
I thought you went down to the Roadhouse, wasn't it?
It's Can't Always Get What You Want by the Rolling Stones.
Oh, well, there you go.
I went down to the demonstration to get my fair share of abuse.
Nathan, could you just present me?
Yeah, sure. Just waiting for you to put something up.
Yeah, you're not showing anything yet.
No, just present me.
Lewis isn't going to do anything. Come on.
Lewis, what's your channel name?
This one is Lewis Hackett. Just go ahead and present me. Yep.
I'll present you. Presenting Lewis Hackett.
Thank you.
Is that
You're more than welcome, buddy. You're more than welcome. You're my favourite baller. You're my favourite baller, by the
Well,
way.
I thought, what about me?
Play what you
Aw.
want to show.
You're incredible.
I'm hot.
No, just present me. Just have a look.
No, you show it first, and then Nathan can decide.
I'll show you yours if you show me
if
mine.
you put it on.
I'm-
screen.
I'm showing it right now. Just
I don't
present.
see anything.
You're not.
It's just your
No, it's-
icon, your troll icon.
Yeah. Just have a look at the icon.
Yeah.
Shuminati
to
likes
do
his
that.
aliens.
Well, the icon is easy to understand.
I don't think anyone can explain what's going on in my picture there. They're trying to hide this from us.
No, it's funny. It might be. It's an interesting hidden little.
It's free energy. They're trying to keep it hidden.
Could be. Maybe it would work like that.
Oh well, listen. I'll tell
Would
you
it
what
work
they
like?
have invented,
Would it work like that, Arwen?
they've invented a machine, or they're inventing a machine. I think it's.
Do you think that could work, Allie? Do you think that could work, Allie?
It's a European effort. It's a European effort, and if you put in, I think they're saying if you put, this is governments that are doing it. If you put in 50 kilowatts of energy, I think it's producing 10 times that amount. It's called ITERS, ITERS or IERS or something.
Enjoyed by Imric. Oh, I'm Rick. How you doing, I'm Rick?
I'm fine.
Good to have you here.
Hey, man.
So what did you say, Brenda? Sorry, did you say something to me?
Well, apparently, Lewis wants people to see his icon, which is showing free energy, which the government is keeping hidden from us. And I was wondering if you thought, if you had a comment on his icon and the principle.
Energy. There's not such a thing as free energy.
Oh, okay.
There's not such a thing as that.
Well, I have a different concept about the free energy thing. What if the government is simply just using it?
And whether you like it or not.
Just present me to everyone, Nathan. I have proof here. I would like an answer to this.
Who's breathing into their microphone? Is that Chris? Someone's got the microphone up their nostril or something.
I don't think so, mate. Maybe it is. Sorry.
What I think is really happening is that the governments are using free energy and they're just camouflaging it for some kind of other type of energy production and taking the savings for themselves.
I know this is that. Just have a look. This is how that free energy works. This is what they're covering up.
That are in on it also to do it. So it's like an elite scam of shortage.
Lewis, that doesn't work though.
That doesn't work?
Oh, really?
Yeah,
No. I think
not
it does.
working. Absolutely, you can see clearly that concept won't work.
Can you?
Need to come up with something better than that, buddy. Sorry.
Arwen seems to disagree with you.
No, that front magnet's pulling the magnet on the boat, and as long as he keeps it away, it'll go.
I don't know if it would actually work that way, but
you don't know that. They brainwashed you, Arwen. They brainwashed you.
Have you ever tried to do it yourself?
Exactly. If I would have to do it myself to be sure, but I don't think it actually can work because the magnet is not fixed in the water.
You're gonna have to go get some experiments of yourself to prove this wrong.
Yeah, that's
it would be fixed to the boat, though, Arwen. You would attach that to the boat.
Hello, guys.
Enjoying by Dawn Treader.
Dangle the one out in front on a pole.
Good to have you, dear. Dawn.
I'm just saying, who knows?
Bear with me, guys. Just want to say hello to our new guest. Bear with me. Guys, hello. Just want to say hello to Dawn. How you doing, Dawn?
Hi, man.
Hey,
Good to have you.
I had to be here for this.
But can we talk about the 138 foot, or are we just going to accept that the Earth's a curve, like Ali said?
Yeah, accept the Earth's curve.
Cool. Okay, cool. Moved on. So we debunked that footage. So we don't need to talk about that anymore. Thanks, Ali.
No, it's not curved. It first goes on in a straight line, then there's a little curve, and then it goes on in another straight line.
Accept it.
A slant.
That's it.
I'm really happy.
It's all over.
I thought it was going to be a lot harder, man. This is really easy.
Yeah, well, there you go. See what happens.
Yeah.
Well, which lighthouse are you talking about? You're talking about the northern one.
The lighthouse.
Boy.
The Maggold. I think we're talking about the Maghold.
Oh no, that's only 60 meters high. That's the one that Gem Panda was focusing on.
Well, we've got the wiki here, and it says it's 213 focal height. So that's to the lens, right
feet.
Above.
That's feet, is it?
Feet, yeah, 213 feet. So it's 70. The height of it's 75 foot.
Yes, that's right.
So if it's on the waterline, it's about 138 feet, right? Missing. Underneath.
Well, if you go to Google Earth, it says it's 23 meters up. But if you actually go to the Wikipedia page for it, it actually says it's the focal height is something like 63 meters. It's 23 meters high, which leaves it 43 meters up. Which I suppose that would put it at 100. But on Google Earth, it says it's only 21 meters above the sea level. So it's quite. I was having problems with that discrepancy.
Yeah, it's too bad somebody doesn't live near there, and they could like take a boat out there and actually measure it.
Yeah, stick to wiki.
They could power their boat with the method I have displayed here. If
They
Nathan
could.
wanna
They could.
So we can see extra because of refraction, but there's still lots missing at the bottom.
Yeah, make
I
a video.
wouldn't mind seeing the picture again so we can see how much is missing. Where
I've got
I thought we established we weren't able to see that. We shouldn't be seeing that lighthouse. I thought we established that.
No, we didn't.
I thought there was a 1,000-foot wall.
No, 1,000 foot
Well, if you
refers
listen to
to the
Nathan
50
and you
miles
don't know
away.
the observer height and blah blah blah, but the reality is there is
The
still
lighthouse
about
shouldn't be seen,
138 feet
correct,
missing
Ali.
from the picture. Roughly.
Correct,
If you look
Ali.
at the
The
picture-
lighthouse shouldn't be seen at all. Correct, Ali. The lighthouse should not be seen at all.
Wrong, Nathan.
That's
There's
wrong.
only 160 feet of curve. There's only
You're getting
160 feet.
You don't want to get confused with this.
160 feet of wall or
Oh,
bulge.
106. So there is a wall.
160 feet. 160 feet.
There's a wall. There is a wall.
Build that wall. Build that wall. Build that wall. Build that wall.
We don't need to.
Build
we already
that
got
wall.
the apparent.
Build that wall.
I'll show you on Metabunk. It's 160 feet bulge.
Oh, go for it. Go for it. Show us.
Okay.
Show us. Come on.
All right. Let me
Go,
present.
Rick.
How do I present?
Present Rick.
Join the ship of fools.
How do I present?
Ali, do you know, it was me and Al were talking last night about how, we can have a perfectly reasonable conversation with you, and then other times, when you're in with flat earthers,
Try and act a big man.
it's not so much a big man, but
Why are you going into this now? Everybody has their own moods and their own.
160
Yeah, we got to let Rick do his thing, man. Come on.
Arlen, you can't tell me you're always telling me what I can and can't talk about. I don't tell you what you
Why
can
do
and
you
can't
bring
talk
up
about.
this now? Come on.
160 feet.
I'm having a bit of fun here. I'm not serious.
160 feet. 160 feet of bulge.
Who
Right
says
there.
it?
See that? Am I presented? 160 feet of bulge.
Yeah,
no
sure, I mean.
1,000. 31 miles away. 0 viewer height. Check that out. 160 feet of bulge. There's no 1,000 foot anywhere on here. Nothing is 1,000. 160. So can we get the 1,000 foot and go to 160? Can we all agree on that?
No.
I don't.
No, wait, Nathan. Nathan. Can Nathan agree on that? 'Cause
I
it's his-
understand.
I think they probably.
I understand you don't trust it,
This,
but I'm just
a
saying.
bunch of numbers,
Yeah, but this is what
Well,
you've been
it's
trying to tell us.
160.
just like that.
There's
that
not
solar
1,000.
system, I think it's false science. I think.
But,
it's
but come on,
deliberate
Nathan's
fabrication
been banging on this
to
drum
bend
about
all the
1,000
real
foot wall.
optics into a globe.
1,000?
system.
Yeah, we're talking about this calculator that we've
I
been.
thought. Hey,
Yeah,
Kat,
no, it's
Kat,
it's your
I thought-
lovely
I
mechanism.
totally agree with you, Aaron. The only real science that we can know is this. If Nathan can screen share me, we can go over the free energy.
Kat, didn't you want Nathan to stay
can't-
out of it? He's moderating.
No.
Now you want him to join in. You better make up your mind. You're beginning to sound like my ex-wife.
No, I just need him to screen share. So
Well, that's
that
good
we
because
can
he's your
go over-
ex-wife.
So I can go over the free
Or
energy.
you want him out. Make up your mind, Catty boy.
I'm glad it's your ex-wife.
Make up your mind. Make up your mind now. Do you want him
I
in
just
or
think
out?
it's a fair point, isn't it? Nathan's been
Wait,
saying
I-
it a lot.
Well,
I know
actually,
you
right.
want to come to his defence, Ali.
That's
But
right,
like,
you
Let's continue the conversation instead of let's not attack each other.
Okay.
Yeah, Nathan,
yeah, I agree, Owen.
if you can
I didn't
screen
think I
share
was
me.
Conversation is the lighthouse is 75 feet tall and the focal height is 213 feet. That means there's 138 feet missing house in Anthony's photo.
How far does the light
So
shine?
138 feet missing. Please show us that in Anthony's photo.
How far does the light shine though?
213 feet.
It's nice
Here
that
it is,
that
right here.
does
How,
them,
how
but
far does the light shine?
if you
It's
can
not
see
the
the
rays.
lighthouse, then you can see it.
113 feet. The lighthouse is only 75, so it's 138 feet below it.
Yeah, but how
138 feet.
shine is light?
Real life observation
Two,
from
two,
math. Okay?
113.
Do you want to put your maths back up,
If
Rick?
your math doesn't add
Put
up
your maths back
to
up, Rick.
reality, then it's wrong. That's how it works.
But it
Right,
does
the
add
maths-
up. You
maths back up, Rick.
Everything adds up.
All I was asking, How far does
From
it
the
shine?
bottom of the lighthouse is all hidden down 138 feet. The lighthouse is 75 feet tall. It's 213 feet to the ground, though. That leaves 138.
Yeah, but what's it rated? What's it
100
rated for the light? How far does the light shine?
We
What's
can
it
see
rated
it during
at?
the day, Ali. Well, the light's got nothing to do with anything.
No, no,
213 feet tall.
Of course,
Doesn't matter. Doesn't matter.
House, not the light, you
What
idiot.
is your point, guys? This is getting really weird.
130.
Well,
Like,
hey,
Arwen,
Arwen,
the
why
point,
don't you just
the
go away
point
then?
is
Just beat it. You're not wanting them if you're going
138
to.
feet is missing. 138 feet is missing in Anthony's photo.
I can show the picture that we
That's
took.
the point. Show the
Let's-
picture then.
Yeah, I'll show the picture.
138 feet is
Yeah,
missing.
but it's not
Yeah, come on,
enough
bring it
according
out
to the
the
official
It's
formula.
Get the
I don't
photo
care
out
what the
of
official
Uh,
formula is.
Oh, really? You don't?
The official height, they are doing any formula other than subtracting 75 from
You're not
213.
using the curve formula?
When was it built?
Nope.
Okay,
not
so
at
you're
all.
saying that it's
No.
faulty. It's not.
I'm
No,
I'm not
it's
using
keep
it.
up.
It's useless.
I'm not saying
Is that what you're
refraction.
saying?
what
You're
Rick's
saying that
saying.
Nope.
the
Nope.
8 miles
saying-
thing.
Nope.
That's
Nope. I'm not,
Everything
I've said
Nicole
that
is in.
nowhere. Said
Was
that
it built
nowhere.
before the
Here's the
cover?
picture.
138,
Here's the picture with the lighthouse.
130.
Right, there's the lighthouse there. It's just to the right of what I can't remember what peak this is now. That is the lighthouse there, and you can't.
It's a yellow one.
I've actually measured that. What you can see there, and you can see just about 20 meters on using my ability to scale things on this now. Now I've worked out what the scale is. That actually is about the. Just
Look at that little thing. Like, even if we imagine we're not supposed to see that, how is that making the world flat? That little white
Because
blob.
138.
it doesn't make the
missing.
world flat.
So can we
What
move
it
on
does
to
is
something
it
else that
negates
does?
the official curvature
move on then?
system because it shouldn't be there.
Y'all-
It should be there.
Y'all have been arguing for 2 weeks that there's no curve. There's 138 feet missing.
No,
so
we've
then we're
not been
talking-
arguing there's no
Well, let's
curve.
get
We've
right.
been arguing there's not the
Why
right
is it
curve.
missing?
We'll admit that
We
you shouldn't be able to see it.
Yeah.
Now,
In other
We
words,
don't care. No.
now we'll move on
No.
to the next point.
Oh, so there is.
138
let me
feet
just, can I just
missing.
finish? Can I just conclude this? The point is, if this was a flat Earth,
Make
This-
concentrate.
this was a flat Earth,
Let's
this
not-
white blob. Ali, please, can I finish?
This
If
is not about if it's flat.
Can you-
This
Owen,
is
can I
about
just
if
finish
it
my
matches up
sentence?
with your
Owen,
ball
Owen,
curvature
can I
or
make my
if it
point,
doesn't.
please?
And
You
it
can speak
doesn't.
afterwards. Right, so this point
How
is,
long will it
Owen,
take
can
for
you
you
let me
guys to
finish,
get it?
please? I will let you finish. I just need 10 seconds. So here's the lighthouse that's 20 meters tall. Apparently it's 40 meters above. So in other words, if this was a flat Earth, this white blob should be up here somewhere, but it isn't. It's down there. Now the arguments over the
There's
last few
still
weeks.
refraction.
Hold on, the last few weeks have been that we can see a bit more than we should. And indeed, if you take the values that Anthony's been offering about his height, we are seeing more of this. But as I presented this morning, refraction can account for this. It doesn't have to be very far off standard for us to be able to see this as we see it now. Thank you. Go ahead, Arwen, with your gibberish.
Oh, no, let me talk gibberish
Okay,
first.
well,
'cause
refraction
I
does a
get
lot more than your formulas actually
No, it doesn't.
apply it.
No, it doesn't.
How do you know that,
Because-
Arwen? How do you
Because
know?
making stuff up.
And I mean, really,
How
Nathan,
do I know it? Because
Nathan,
there's
if you could
always
present
a
me-
slant. It always starts.
There's
The
always a
curvature
slant of
always
what?
starts in the super far distance.
Okay.
Suddenly, then
Let's-
after a certain point, it stops curving and it keeps on
Okay,
going in a
okay,
straight line. And
let's
it's
write
very
down-
clear you get to
let's
see
write down,
that.
Let's write down this gibberish. This is what Arwen thinks. Now,
No,
Arwen
this is
thinks-
how you get to see things
Arwen
thanks
thinks-
to
so
refraction.
Hold on. I want to write this gibberish down.
There's
Arwen
no,
thinks what?
there's no
What do you think?
consistency in
What's
its
What's the
curvature.
first point you want to make? Give me a sentence. Give me a sentence.
Come on,
a
Owen.
concise sentence of what you think about refraction.
I
Tell
think
me.
that the refraction
I like the
system
writing it down bit.
that you're using are fraud.
We're using a
I think
fraud.
you
Okay.
knowingly,
We're using
or
a
maybe the
fraud.
one that
Okay,
handed
got that.
these
Okay, we got
formulas
that.
to
Hold on.
you,
Hold on. Let's make this point. Hold on,
knowingly
Arwen,
tampered
Arwen.
with the
You made one point. You
values
made one
to
point.
make
Second
it
point.
fit
Second point.
your
We're
globe.
using a fraud.
That's
Next
what I
point. Next point. You've got point number one. We're using a fraud. Next point.
I'm
Well,
not
that's a
using
pretty
a
big
form.
point.
I'm just
No, this is what
subtracting
Arwen thinks.
75 foot from
It's
213.
point number one is we're using a fraud. I want to know what point number two is.
There is no point. 130.
There's no point. You've embarrassed him enough. I mean,
Point number two
138.
is that the
Y'all have
actual
fun.
visuals. Hey,
The
do I
actual
make my
visuals
point or
are-
not?
The actual
get to make my
visuals.
point?
What, sorry. The actual visuals,
Okay,
what?
yeah. Point number 2 is that the actual visuals do not match up with a consistent curvature.
Do not
You
match
get
up
to see
with
a starting curve
consistent
in the
curvature.
far distance, always in the distance, never close up,
you
always
gotta
in the
do one
distance.
point at a time.
Okay,
One
Then
point at a time.
suddenly it
let's
stops
make sure- okay, so
curving
the-
and it
okay,
goes
well,
on
I'll
in a
put that
straight
as a,
line. And when it's
okay,
clear
we'll do
enough,
this
you get to
as
see.
2A. Hold on.
Guys, you can't both
Owen, I
talk at the
can't
same
hear
time.
all this
Owen,
gibberish.
you have to
That
have
is
some
the
decency and
practicality.
let
That is
people
what you
talk.
actually get to see.
So right, so what you're saying is that as things further away are not, they don't match the formulas as they get further away.
Yes.
The distance, right?
There's
So,
no consistency in the curve
right,
at
okay,
all.
okay. So
It
things
should keep
as they
on going.
the
and it
things
doesn't.
as they go further away, they do not match the formula.
Yeah.
Do not match the formula in size, right? Do not match the well, we call that the accepted perspective formula or something. Accepted perspective formula.
You got to put the a knot in there, or change it to don't.
Oh, yes, thank you.
Yep, no problem. Now, if we
Thanks.
could just, Nathan, if I could get you to screen share, we can go over the free energy conspiracy you've all been brainwashed to ignore.
So, in what basis have you got other than your opinion for this, Erwin?
Well, a lot of observations, and
Give me one.
got
Give
a
me one.
really
Give me
good.
one.
I
Give
got
me
a
one.
really good YouTube
Give me one.
video just yesterday that
Give me one.
demonstrates this exactly.
Where? Sorry, I missed where this was.
Well, it's in my upvoted.
Show it.
list.
Share it.
Okay, yeah. I will look at
Oh
it.
man, yeah, I forgot. I haven't checked Arwen's upvoted folders in a long
Yeah,
time.
I
I've been
don't
meaning
care.
to
You
get
don't
on
have
that.
to. You don't have, just stay away. That's fine with me.
So we just
No,
get
I'm here to
0.3
help
written
you
down.
understand that you've been brainwashed to not accept free energy.
Yeah. You can stop talking now.
Thank you. But if Nathan can screen share me, then it'll all
Okay,
be
while he's
explained.
doing that, we've got 3 points down here so far that Owen's made. One, we are using a fraud. Two, the actual visuals do not match up with consistent curvature, and that specifics of that is that as things go further away, presumably the size they are in the distance don't match with how big they should be, or when they come close, or I don't know, he's talking about a moving thing, or there's a building in the distance and a building close to, and they don't match the perspective formula if we know the heights of those things. Presumably that's sort of what he's implying. So far these are the
Yes.
Do I need to keep that?
I'm joined by Sleeping Warrior. Good to have you here.
Hi, pal.
Play it again. There you go.
Okay.
This is what I'm talking about. The curve starts and then it keeps on going in a straight line. It doesn't increase. It doesn't continue to fall as it should in a literal curve.
Well, it did. It carried on falling. What are you talking about?
That's how visuals actually work. Thank you.
No, if that was on a flat plane,
Let's see that again. Let's see that
would
again.
not lose the bottom. What's obscuring looking at the bottom if you're on a flat plane?
You're telling me you
Optics,
modelled that on flat?
refraction that bends the light up.
Oh my
That's what
gosh.
that
Can you
does.
send me the
Yeah.
file for that?
Look here. This guy actually knows
Well,
what
can
he's
you
doing.
send me the file for that? Because that's not on a flat thing, is it?
Sorry,
Not
Alwyn,
flat.
can you just play it again and make
This
it
is
full
on
screen?
a table. Look at the size of the object.
So you're
Can you
telling
make it
me that
full
if I so
Love to
does
see
this
the
effect
file
only
for that.
occur over miles away, or if I look on a table, can I emulate this by
distance.
putting something on a table and looking along the line of the table?
Any distance.
So right, so I can put
How
something
it
on the
will
table.
work no
Hold on,
matter
hold on.
the
Let's just
distance.
establish this. You're saying I could put something on the table I've got downstairs, which I've got. It's quite a long table. I've got a 10-foot one.
If you
I
put
could-
the viewer right, like
So
the
if I put my
camera
eye-
itself,
if I put
the
my
actual
eye-
lens
so-
right on top of the flat
Right, so if I
table,
put my eye
then this
at
is
the
what
very
you'll
top
get
of
to
the
see.
table,
If it's up higher, then
and I move
this
it
thing
away, I
will
will
start
lose
further down the
I
line.
would lose the bottom of the thing. The bottom of the thing would disappear if I had my eye right on the line of the table and I move the object away, say a pepper pot or whatever, anything I happen to have on the table, I will lose half of it as it goes down the table. That's what you think, do you? It will disappear eventually. If just at the end of the table, I won't be able to see it
I
anymore.
didn't make this here, and this is not a flat earther. Okay.
Well, okay,
This
I'm
is just
asking you,
somebody who
Owen. I
actually
just asked
knows
you.
optics.
Are you saying that if I stick my eye on the end of a table and I stick a pepper pot or anything on the table, I move it gradually way further from me, it will disappear from the bottom up until eventually it disappears at some unspecified distance, or at least a good proportion of it will disappear as I move it down the other end
Not
of the table. Is
with
that what you're
eyes
saying?
of your size, no.
So what size? Right, okay, so that won't work.
Very
You just
small
said.
ones.
So I have to be an ant size eye, is that right?
Mice size. Probably.
Do nicer. Okay, would it work then if I had a bigger scenario with a longer, flatter, say a runway or something like
The
move
bigger
something?
the eye or the lens or whatever is, the further away this effect will start.
And what basis have you got for that?
Just
Why do you think a bigger
logical
eye
reasoning. This is just how
changes
it
the way
seems to
that
work.
the light rays come to you? Why does the size of your eye have any effect on that whatsoever?
That's optics always do.
You don't have.
They
Okay, you say
always
you understand.
relate
Okay,
to the
okay, so you
observer.
understand
That's how
optics, do
optics
you?
work.
Hold on. You say you understand optics, is that right?
I understand. I got a feel for it. I got a.
You've got a
pretty
feel
good
for it. So you
grade,
don't have
back in
any
the day.
numerical. Do you have any numerical understanding? Can you give me a formula for the focal length of a lens?
No, I'm not into formulas. I
So
don't
you
know
can't
that
do
kind of
formulas.
stuff.
You can't put any numbers on this. You've just got a feeling. That's the whole
I did
basis
the
of your
study.
argument.
I passed
You
the
haven't got any
tests. I got a
evidence. You haven't
really
got any
good
visual
score on
evidence
it.
of this happening.
I
and you
just
haven't
am
got
not
any
very
math-
good with formulas. I'm sorry, I'm not a math guy.
Yeah,
But
which
I
is very
can
evident. You're a
point
moron.
it out. I can describe it. I can
you understand
explain
trigonometry?
its functionality.
Do
That's
you
what I
understand?
am good
Do you understand
at. Okay,
trigonometry?
I'm sorry I don't fit your math world.
Do you understand trigonometry?
Yes, I do.
Do you understand what a sine function is?
No, I don't understand the
My God, you just
terminology,
said you
but I
understood
do understand how
and
trigonometry
you don't know what a sine
actually
function is.
works.
So that means to say, if I gave you a problem here, so if I drew a triangle here, if I drew a triangle, if you presume you're still sharing, if I drew this triangle here, whoops, didn't mean to do that. Cool. I drew this. If I just go back to that, apologies. Just go back.
While you're doing that, Rumpus,
I'm not into math.
sorry, Aaron,
Yeah, but this is this. You just said you understood trigonometry.
I understand how it works.
He's demonstrated before. He doesn't, to be honest.
Yeah, I did. I understand it perfectly. It's a matter of angles, and it's only angles, and then the actual
you contradicting
size or distance
is
are
because you've been
inserted somewhere. Because I know by base logic that
Nathan,
you
you can
can't
share my screen.
reduce size or
Right. So
length
you understand trigonometry
just
and if I,
from angles. It's
right. Hold on. So if I told you
know
this was,
as a
so if
fact.
I told you this was 5
It's
in
basic
length,
logic.
and I told you this was 4 in length, could you tell me how big this is here? Are you capable of doing that?
Hold on.
You capable of doing that?
Do you know that?
Now
Do you know
this
what that is? That
this is
is that
I did
trigonometry
train for
or is
this
that?
type of
Do you
thing.
know?
Hold on.
Is that that you've been showing?
Is it 3?
Yeah, it is 3.
Right. And how did you work that out?
Because
you
I use
multiply
every
5 by itself, the 4 by itself, and then you add them up, and then
I've used it
you.
for 20 years in my work.
I want to hear
a line perpendicular to the house.
Owen,
It's
how
always
did you?
easy. 3, 4,
Owen, how
5.
did you? Ali, I'm talking to Owen. Owen, so how did you get that 3?
No, it was me that
I
said I got
just
it.
told you. You multiply the diagonal because it's
So I multiply the diagonal.
because it's a 90-degree angle. This
Yeah.
works only at between the 4 and the question
So what do
mark.
I multiply the 5 by?
Because it's a straight angle triangle.
What do I multiply the 5
It's just
by?
Pythagorean
What do I
math. You
multiply the 5 by? You said I multiply
Dude,
by
can I
something.
explain it or not?
Well, I'm asking you what to multiply the 5 by. You said you were going to
By
multiply something. Tell
itself.
me. By itself. Why do you do that?
Because that's how Pythagorean math
Right,
works.
good. So you do know about Pythagoras, right? Okay.
I do know that. I just
Brilliant.
said that.
Well, that's a good. Okay, now let's.
He did say that, in fairness.
So right, okay. So now let's say we don't know the length of this, and I said this angle here was 30 degrees. Could you now tell me what the what this question mark is?
No.
You couldn't do that.
No, I never.
Right.
got
Well,
to that
did you
part.
know that most 12 or 13-year-olds can do that problem? And yet you claim to be an expert in optics, you moron.
Anyway, once
This
you've done
is something that
Rumpus,
11, 12-year-old would
you've
be able
said that.
to do.
When you've done,
don't
just could you
understand.
stop
are
screen
utter,
sharing?
utter morons.
Rumpus.
You don't have
I
to.
do just know basics. I'm not.
You
I
don't
told you,
even
I'm
know
not very
basics.
good at
You
math.
don't
I am
even
very
know
good
basics. You're a
just
moron.
describing.
You're
Rumpus,
less well
Rumpus,
educated
sorry
than
to interrupt
13-year-old, and
you.
you
Rumpus,
think you
before
can
you
contribute
just
to
give him a
that.
barrage
good
of
for you.
calling him a moron.
Utter
Rumpus,
moron.
Keep the insults
no,
up.
come on.
It's right.
Rumpus.
Yeah.
All right, I'm gonna have to turn you down to get my point in. Right, Rumpus, please, when you're done presenting, can you just stop screen sharing just so we don't give the viewers epilepsy?
No, come on, guys, come on.
He's been brainwashed into believing
hear me,
ridiculous
Rumpus?
things. If you could screen share, then I can go over the details of his brainwashing.
Yeah, Rumpus, could you stop screen sharing? It's just once you get into conversation, it just causes a bit of epilepsy.
Yeah, okay.
Thank you.
The answer's 4.33, isn't it, Rumpus?
Nathan, if you could screen share, then I could go into the
It
details.
should be 2.5. Because
I'm glad you're all divided about it.
The first
Means
one
that
was
I'm not that
Pythagoras.
stupid for not knowing.
This is trigonometry.
The second one was trig. Was it 4.33? The answer.
No, it should be 2.5. I mean, that's off the top of my head. I'll have to quickly calculate, but I think it's.
Sorry?
I think it's 2.5. Let me just check. I think I haven't checked it. It's just something I came off the top of my head, but let me just quickly check. I think you'll find that.
Oh yeah, it was 2.49. Yeah.
3.5's close enough, man. It's
No,
close
it's
enough.
2.49.
Close enough.
No, it's not.
And
I'm glad you've all mastered it because you
Yeah.
are absolutely divided about the
Can
answer.
we talk about what we were originally talking about? This missing stuff. This is what Riley's in even.
Okay, wait, concentrate. Nice one, Cat. For the
No,
night.
we're talking about the 138 feet missing, or roughly. This is what Riley came in for.
Sorry, I was having a drink. You just caught me slightly off guard. Right.
It's okay. That's all right. Nathan, if you can screen share, then I can go over the details of your brainwashing.
Okay, so just screen share Lewis. I'll come back on when you finish with Lewis.
I don't think you've been keeping up with the meme, right? It's like... But anyway, come on. Let's talk about this. I've been hearing about this all day. Need
Does
to talk
Lewis
about
not
it.
screen share? Is
Rick
that-
really wants to talk about it.
Yep.
Everyone was me and talked over Rick, so it's time.
Just
Come on.
screen share, and you've all been brainwashed. Free energy is real. If you can't explain what's wrong with this well laid out diagram, evidence, proof that I've put before you, then you're demonstrating the brainwashing.
So can we do it now? Come on, because otherwise Rick's never going to speak to me again.
Yeah. I'll do it, but I'm hoping that
you know
Lewis
what we're talking about because we were talking to Rick about it, right? So
I'm hoping that Lewis will be respectful whilst I make my thing, and then once I've said my piece, it'll be the ball will be within the baller side, and then we'll carry on tomorrow.
Because you understand, Ali conceded this point that he thinks it's a curve.
Ali conceded the point.
Just one part.
Did he?
I'm joking.
Just
Go
a
on.
small part, so.
Right. So.
Yeah, I conceded.
Okay,
Just
if we're going to get an
imagine-
explanation out of him, in the same way you all gave a lot of respect to Rumpus earlier this morning, can you just give Anthony Riley a few minutes
give me a
just
minute.
to go through it without
give me a minute,
interrupting him?
Right. So the only criticism or the only critique I've seen so far that is credible is Imrich's. And he's pointed out quite rightly that there appears to be missing land underneath the lighthouse. If we're all prepared to agree that we see all of the lighthouse, which by virtue of the gap underneath, I don't think anybody disputes that there is a gap underneath. The block has been put back in to show where the actual horizon should be, proportionate to the size of the lighthouse that we see. So this is an exact replica of all the dimensions so that people can actually see what we're looking at and how it should interfere with, or how it should interact with the observation. And
I
clearly,
don't see what this has to do with free energy.
Lewis.
come on, Lewis, be respectful. So I agree, and I'm happy to concede that Imrich's point is quite correct. Whether it's exactly 138 feet or not is debatable. It's moot. I'm prepared to agree that there is a segment missing. Now, Rumpus said before, and don't respond, Rumpus, this is just to quote you, that can be quite easily explained with refraction. Now, I don't accept mathematics proves anything because I like to see the evidence to prove stuff. But what we can see in this evidence is that the bottom of this missing block of rock lines up with a line that goes right the way across the screen here. Now, this evidence that I'm going to cite, and I'm now going to make an assertion, and if anybody can prove me wrong, go for it, because this is I'm going to assert that this is actually a mirage that we're looking at, and what's happening is the water below, there's another band that's the same band that's on top is underneath. I think what we're seeing here is mirage. It's non-standard refraction, but it's limited to what we're seeing here in that the water below is being created a mirage on top. It's a superior mirage, and it would be upside down. So in other words, if there was a boat on the horizon, it would flick upside down and it would appear on top. So I'm going to assert that we're seeing a mirage. I'm going to assert that the water's upside down and it's miraging on top of it, artificially raising the height of the horizon. And really the water level is exactly where this rock should be. And we have a small amount of a mirage on the horizon. That's the extent of the non-standard refraction, and therefore, evidently, we can see this in the image. Now, I accept it's open to interpretation, and I accept that not everybody will agree with me, but at least you can all see that there's a lighter band there underneath where this lines up perfectly, and it's not a crazy interpretation to suggest that the water might be miraging on top of it like a little tiny bit, and that would be where the water's gone.
If
Now,
we're both going to invoke refraction, should we just say move on? Because
I have to agree with Anthony here.
Has Anthony finished?
And you can see in the image here that there's a superior mirage on my image.
Let Anthony finish his
see if he's finished.
It is.
It's flipping.
Lewis, you're being naughty. Stop it.
Well, he finished it as.
Well, has he? I want to know if he's.
No, I haven't finished. I haven't. I just got a second part to it. I have got a second part to it. If people are generally prepared to accept that there is a line in the image here, and it lines up with the exact proportions of where this should be if it were a flat plane. If you're prepared to accept that there's a mirage on top of it, that takes us to a point that we can test it. And the point that we can test it is, can anybody model, because I've got the answers already, but I'm going to give you guys a chance to see if you can do it too. Before I'm not going to drop it on you. I'm going to give you a chance to go away and consider and see if you can come up with an answer.
I got it for you right now.
Can you model and show how mirages work on a curved surface and show how they don't, or how they differ to how mirages work on a flat surface?
Now, I got an answer for that right now.
I'll tell you my position. I've got it modeled both ways already. I know what mirages do on a flat, and I know what they do on a curved. But I'm now going to, because I've made the assertion that this appears to be a mirage, I'm now going to assert that therefore if you accept that this is a mirage by virtue of the evidence.
Does that little grey line go all the way across the whole panorama?
Then we'll, well, no, because it goes further across, but it goes across. I haven't got that part on the picture. I've only got this as a picture. You see, this is the extent of the picture I've got.
Yeah, but he's asking if it goes on the other parts of the picture, which you must have, whether it continues.
Well, I don't have the screenshot. I only have this as a screenshot.
Yeah, but you might have a screenshot, but you must have that picture.
You've got the same picture that I have, so you can check it yourself. Okay. So rather than make me say yes or no to that, I only have what I'm looking at in front of me here, which is like it's.
So you're now an expert in modelling mirages.
He absolutely is.
I have modelled the mirage on a flat and on a plane, and I can compare and contrast it and demonstrate it. But I'm not.
We can just agree. We both say refraction and move on to another point. And just
your definition of refraction is
hold on. Have you got any more to add before we just all chime in? Is there any more to this, Anthony?
Yeah, I'm happy to say that there is evidence of a superior mirage in the picture. If you're all prepared to, I mean, this is my position. However, it still remains that none of the lighthouse should be seen. And just to correct the position about the 1,000-foot wall, Nathan was obviously away from the microphone at the time. On this observation at the 31 miles, that's not where the 1,000-foot comes into it. The 1,000-foot comes into it at the far left of the picture, where we're looking at 50 miles. Exactly. So that's where the 1,000-foot wall comes into it. At this Morgold lighthouse, it doesn't. It's only 300 feet. So
I see no evidence of a mirage at all.
Yeah, you don't see anything, Brenda. So I'm not really talking to you. I just wanted to put that out there.
So is that the end? Hold on. Is that the end? Is that any more to your presentation?
So that's the updated position on the flat Earth debate. I'm asserting that we do see evidence of mirage in the image, and it's supported by the white line or the pale blue line. And I'm going to give you guys a chance, and maybe we could reconvene tomorrow evening or tomorrow morning, and we can basically we can talk about mirages.
Baby's always dancing.
Okay, so I completely agree with Anthony. We can see the evidence I'm presenting here that if Nathan, if the screen share, that the light blue band right on the surface of the water here is quite clearly a mirage, inverting this magnet here. As we all know, opposites attract and like poles repel, flipping this magnet so that the opposite poles are repelling each other. But clearly we know, because there's attraction going on here, this must be an inverted magnet. So right there we can tell that there's a superior mirage flipping the image and creating the distortion we see. Free energy.
It's a good distraction, man. Free energy is the best distraction.
Yeah.
The best possible option besides flat Earth. So well done.
Riley's just making it up that there's any kind of mirage. There's no evidence for any kind of mirage at all.
No evidence.
I agree there with you, Brenda. I would say that what has been asserted by Rumpus is that the entire island is being miraged uniformly up and down the coast.
100%, Nathan. The entire island is flipped upside down by a superior mirage, putting the base of the island up.
As I've explained, not screen sharing, am I?
Can someone explain to me why the 1,000-foot wall is diagonal down the photo to the left? I don't understand that.
I could try if you could, if I can.
Just quickly before you do that, I'd just like to point out this.
Sure. You go ahead, Rumpus.
I've demonstrated modelling here what happens when light leaves one medium to another, and the atmosphere is effectively a series of layers of different refractive mediums because of the difference in density that occurs as it goes from sea level upwards, and you get this sort of refractive effect where you get little changes. If you were to model it as a series of pieces of glass, and then eventually you get to this situation where if you're looking horizontally, you get curves. This is the normal looming refract. This is the standard type refraction behavior where you get this sort of bending. And so it's everything. Even if you're looking at merely something 200 meters away. And what I was going to include in this presentation, I didn't do. Jordan Nathan did some work on this across his lake of about 2 miles. And he established that he was getting refraction of about an inch, just over 200 meters. So basically, whenever you're looking horizontally, you're looking, if what Nathan wants to call a mirage, means that light does not travel in straight lines when you're looking horizontally. So you're always looking just about a mirage, even at something only 200 meters away, because it's being bent. And that's all that's happening with the whole line. It's being bent to a slight degree so you can see slightly more around the curve, but that's what happens to standard. When you're looking vertically, it doesn't happen. It's only looking close to the horizontal, you get the effect that I'm describing here, where you can see things like the sun or whatever, which is a well-established fact, from below, below the horizon, and they have to allow this in tables for sunset and where the sun, for instance, you can actually see it underneath the horizon because of the bending that occurs. And as I demonstrated in the video, if you look at the speed of stars going towards the horizon, they slow down. They have a uniform speed when they're sort of up in the sky. When they come towards the end,
bodies have nothing to do with the actually earthly observation.
I completely agree, Arwen. You have to go back to the free energy every time, and the superior mirage flipping the magnet.
So as I demonstrated here, you can see if you watch a star as it approaches the horizon, very close, where you just start getting higher refraction because as this table here shows, you get refraction. This is the degree of elevation along here. As you get down to very close to the 0 degree, looking horizontal, the refraction goes up hugely. And you can see this for yourself. If you go out and look at a star and you take a video of it, you'll see how it approaches the horizon. It slows down because of the refraction. You're effectively seeing it behind the horizon, and then you effectively get the same effect that happens at sunset and sunrise, which appears, and they make corrections for this in the tables they show. They know that the sun is actually effectively below the horizon when you see it, and they make allowances for this. And you can see it with stars. You could do it yourself. You could take a video of a star going behind the horizon, going down as it spins, and you'll see it slow down. So whenever you're looking horizontally, you are effectively, if Nathan wants to call it mirage, that means you're seeing a mirage almost all the time. Even something only 200 meters away is 1 inch higher with standard refraction than it actually is in real life with a straight line towards you. So
Arwen.
That's correct for the heavenly bodies.
I have a question for you, Arwen. Did you know that the video you shared was a model of a sphere Earth and not a flat?
Yeah, had to be.
I'm sure.
Oh, I just had to, well, it couldn't be a flat
Did you know
one, could
that?
it?
Oh, yeah.
My God, what a plonker. This is a guy who doesn't know 13-year-old trigonometry.
Did you know that the video you shared was a model of a sphere? Was a sphere Earth model and not a flat Earth?
Really, with a computer on it?
You have to go.
Was that it?
I thought it looked rather
Been joined
familiar.
by P Mars. Good to have you,
was
P Mars. Sorry, bear with me, guys. Bear with me, guys. Hello. Hi, P. How you doing?
Hello. Hi.
So you had no idea of what you were even talking about in the model that you gave as evidence, right? You had no clue.
I thought I was looking at a computer on a table because that's what the object looked like.
I know.
Sorry to interrupt you again.
If that is really the case, Brenda, then the entire
bear with
thing
me a
is
second. I just want to make a couple more introductions. Arwen, sorry, bear with me. Sorry, guys. Hello. Philip, how you doing? Good to have you here, Philip.
Thank you.
Oh, one thing I would like to show,
Rumpus. I've just got a couple of guests I need to introduce. Rumpus.
Hi, Nathan.
Sorry.
How you doing, Philip?
Hey, Nathan.
How you doing, Nathan?
Sorry, try that one more time, Philip.
I thought you were more creative than that, Owen.
Can you say hello, Philip, just so I can check we've got some audio?
Okay.
Hi.
Can you hear me?
Yep, loud and clear.
No, I
Well,
can't
think I was
because every
trying-
time you talk, we've got unfortunately loads of globy trolls that just want to disrupt things. Try one more time, Philip.
Stop that globy trolls.
Like
These globy trolls
Lou,
really
he
need
thinks
to
he's
learn a
funny.
lesson about
Nobody's laughed
respect.
so far, but he thinks he's funny, which is amusing to him, I guess. Anyway, how you doing, Philip? Good to have you here.
Hey, welcome to the panel, Philip.
Hi, how's it going?
Very good.
Interesting conversation.
Right. I just wanted to show this from the thing I wanted to show you this morning about the superimposing a thing from Google Earth over this image of Toronto, which shows the refraction varying from almost no refraction through standard refraction to a moderate amount of refraction. And so you can see here, this is the CN Tower from about 20 odd miles away, and this part of the CN Tower is correctly scaled, appears correctly, and it also appears in probably correctly positioned with respect to the horizon. But all this stuff here is all compressed and also lifted up, because if you then compare that with the Google Earth model, you can see that the stuff is appearing, and this is obviously proof of a spherical Earth straight away.
No, it's not.
Oh, absolutely.
Can I just ask Rumpus a quick question? Rumpus, sorry to ask you. We did it earlier, all of this. No offense. I know you've got it slightly better now, but I've sat through it once.
Okay, I just wanted to quickly
just one more thing. So what Anthony Riley has done, after lots and lots of criticism of the island and its lighthouse, the one in question, he's then gone to the image and demonstrated something on it. And what we are doing now is going, quarter of the way around the Earth to look at something totally different, totally unrelated, to give examples. Hold on, I'm nearly there, Rumpus. Nearly there.
Yeah,
I'm nearly there, Rumpus.
He didn't demonstrate anything.
Nathan's almost there, guys. He's almost there. He's going to come in a second.
Okay, thanks. So.
No problem. You're welcome.
You did make me laugh, bastard.
Basically, Rumpus, please, man, because we need to talk about this other issue, because we've been talking about refraction for days.
Yeah, okay.
So what do we have to do? Refute Anthony's?
Yeah, which is obviously idiotic.
Yeah, it's completely idiotic. So we
got. I mean, I've just demonstrated that
next half hour.
And it's amazing, though, that he denied. I mean, he wasn't prepared to accept.
I didn't actually get to the end of my point, Rumpus. So I didn't get to the end of my point. I'll have another bash now, Rumpus. So what we had was Anthony Riley showing us on the
I'm
picture.
talking about that. I'm talking about that.
Sure. Just let me just get to the end. I didn't get to the end of my point. I was trolled, Rumpus.
Nathan, I'm talking about Anthony's point.
I realised I gave you 20 minutes to talk about it earlier on the earlier show. Literally today.
Nathan, I'm talking about Anthony's point.
Right. Well, what we have is a picture of a tower.
And I know I'm showing the tower.
And Rumpus, can you just let me speak, please?
Just let him talk. He's really trying to get this out. He's been trying to for a long time, but I made a joke earlier and it made it tough.
Thanks, Lou. So the image that you're showing demonstrates effects of refraction, and those effects, this compression, the stretching, parts of it being blocked at the bottom, you're not demonstrating any of those effects on the image of the Isle of Man.
Correct.
If you want to have a good image, you better limber up.
Hold on, Lou. But what you are asserting, Rumpus, is that all of the effects are invisible. We can't see any of them.
They can, because they're raised. That's the effect. The only effect when you have minor levels of refraction, all that happens is it lifts up the image. Looming, just when you're having minor refraction of the type we're talking about, all that happens is it just lifts. You can see further around the curve, and it just lifts the image up by a few 10 milli.
How in terms of that lifting, Rumpus? Sorry,
Rumpus. Exactly what it is.
Sorry, I just want to ask a quick question. In terms of that lifting, hold on.
No.
In terms of that lifting,
okay.
What's it lifting it above, and how far is it lifting it?
Okay. Well, I'll go back to screen share so I can show you exactly that.
We already know in feet already how far it's having to lift it, though, don't we, Rumpus?
Right. Here I showed you, and I went through this. Do you accept that if you had a sphere surrounded by...
No, Rumpus. In feet, how far is it having to be lifted?
About 10 meters.
10 meters. Which part of the island? Hold on. We have a lot of island behind varying degrees of curvature. So if you could be a bit more specific and just tell me which part of the island you are saying is being lifted up 10 meters.
All of it.
So the entire island is being lifted up 10 miles, in spite of the fact that the curve that it's trying to clear varies from 300 feet to about 1,300 feet.
No, the curve's the same. Look, can you not?
No,
see
the
this
curve
diagram
isn't
I've
the
got
same.
screen
The
shared
island
here?
goes over the curvature and becomes further away from us.
Right,
That's why we
right,
have
the
further
further
points on the
things
island.
the more they get lifted. But the things, for instance, some of the images, the particular points, things like the lighthouse.
Okay, the lighthouse.
big-
Rumpus. How much lifting is occurring in feet? And why is it being lifted, please?
Right. Okay, and I will explain to you again. It's being lifted because light does not travel in
feet.
straight lines.
In feet. No, I don't want an explanation. I want you to tell me in feet. In feet. How many feet is it being lifted up, and why is it having to be lifted?
Yeah.
Right.
Yeah,
And if you look at this little diagram here, which where was the one?
It's just an estimate.
Right, here
Just
we go.
an estimate
Can
in
you see
feet,
this
Rumpus.
observer? Can you see this diagram?
Rumpus,
There's an observer
Rumpus.
at O, and he's looking at the horizon at G.
I've seen this,
And if-
Rumpus. You showed me
Right,
this
then
morning.
why
I've
are you
seen
asking
it.
the question? Because
I'm
what
asking you a
happens is-
question about how many feet specifically,
And I
or
told you
roughly,
it's 10
whichever you
meters,
choose,
and I'm
it
sure-
is
and you
being
said-
lifted
you
up.
asked me why?
Can
and
you
I'm
guys possibly
Hey,
just
Owen,
illustrate
You can't answer me, Owen.
once in your
Owen,
lifetime?
At this
Owen,
stage,
you can make
I
a
give
point.
up. I'm not going to get a
Nathan,
straight
Nathan,
answer out of you,
please,
Rumpus,
Just for
clearly.
Why-
clarification, we need to get the images shown on for the audience because the audience can't see. Just for clarification.
Am I not
Okay.
sharing?
Yeah, but what I want to know is why is Nathan asking about the lifting? We're talking about, and Riley said that there's some sort of mirage that's brought the sea horizon.
Louis, can I
What's the
just finish my point here? Just very quick.
Okay,
You've got
man.
20 seconds.
All right.
Because he's asked me a specific question. Why is it lifting? And he
No,
said,
that's not
how
what I
much
asked.
is
I
lifting?
said how high in feet is it being lifted, and what is it being? Why is it being lifted? What's it? No.
Right,
How
I'm-
many feet is it having to be
claiming
lifted
35
by?
feet lift.
Simple question.
Riley is claiming how many feet?
It's just a number with feet afterwards.
Well, okay, that's okay. It was about 15 meters, which I suppose is about 40 feet.
So it is being lifted. The lighthouse is being lifted. How many? 40 meters? 50 meters?
No, I told you 25 meters.
25 meters. It's being lifted. And why is it being lifted?
Right, and this is why I've got this diagram on screen to show you. If you have an observer and they're looking at a point on the horizon at G, and you have the bending of the light, if you can see my pointer, you can see that in fact you can see the point at H. So if you think of the base of the lighthouse would be here, which you shouldn't be able to see if there was no refraction, but you can see the base of the lighthouse.
Not shouldn't be able to see if there's no
because it
refraction.
follows
It
this curve.
shouldn't be able to see
And
because
therefore,
there's
the base of the
an
lighthouse appears at
obstruction.
J.
But there
Base
is
of the
all I want you
lighthouse
to say
appears at
is
J,
because all I'm trying to get you
H.
to say, Rumpus, is it's having to be lifted because the curve of the Earth is blocking our view.
Riley's upside down mirage.
I'll try it again. It's all to do with the bending of the light. If the bending of
Why
the
is it having to be bent? What's it bending around?
But the bending of the round occurs because of the graduation, the densities. I explained here. I thought you understood this. If
But
you have
why?
a graduated density,
What I'm trying to
you'll
get
a
to, Rumpus, is we either have a direct line of sight, in other words, there's no bending required,
it's always bent.
or
I explained
there's an
it.
obstruction which has to be cleared. Hence,
Nathan.
it being lifted up and the light bending.
Nathan, can't you see from this diagram here what's going on? If you want to look, I'll draw in the lighthouse on here to make it absolutely clear. Here's the base of the lighthouse. I'll draw it in here so you can see where the lighthouse. Right, oh bugger, there. Right, so the lighthouse is there. The base of the lighthouse is below the. Sorry, let me just move.
Just say it. Below what? The curve of the Earth?
Between the direct line of sight. So if you follow this, if you follow that dotted line,
finally,
the dotted line, this obscured so this is your direct line of sight with a straight line of sight, which doesn't occur in real life looking horizontally. But we'll just do this for the diagram because that's how we describe it being behind the curve. Because we just consider the straight line case, and then we say if it's below the straight line, it's behind the curve. So you can see the base of this thing here is behind this G point, but due to the refraction, so in fact I'll put it at H. So here we'll put it there. So we'll put it there. So, but here's the base. Here's the lighthouse with its base. It's below this line. I'll extend this dotted line here. What the hell? Oh, sorry. There. Right. So you can. Am I still going? Can you hear me?
Yeah.
Right, great. So there you go. So there's the base of the lighthouse with the bottom of this block. And what we call below the curve means if you to draw a straight line from the observer, hits the horizon, the base of the lighthouse is below the curve.
You can't
now,
teach someone with no trust. It's impossible.
So if we now put it here, and I need that copy that here, but in the refraction case, what happens is that this light from H, because it's bent, appears, if you then, because we assume in our brain that everything's coming in straight lines. So we see that ray of light that comes in, you can see this far of light comes in here and hits the observer, but it comes in at this angle of the dotted line. So what was at H appears at J. It appears above the horizon, even though it's below. When we talk about below the horizon, we talk about in comparison to the straight line. In the straight line case, we then say that's below the horizon in the straight line case, even though it comes above the line, above the horizon, this line, but the human eye assumes it's a straight line. It comes in at this angle of the dotted line, and it appears at J. It appears above the horizon, even though it's below the horizon, just like the sun is below the horizon if you draw a straight line from the horizontal, when in fact it appears above. It's really, really simple.
You're really, really patient, Rumpus. You went through the exact same stuff last year.
I know.
I did.
Right?
Hang
on. The only conclusion you could come to after you went through everything else is that we're dealing with a mirage as well, isn't it? So you take the
Well,
side.
it's refraction. It's refraction.
Hang on, please. Now, if I
yeah, just hold on. Let
We're
Pete
talking
finish
about the obstruction, guys. We've been talking about refraction.
So there's no
seriously
obstruction.
for days.
Do you appreciate there's no obstruction here? There's nothing for it to leap over or leap through.
No.
Just simply follows the line of refraction.
See the 100 feet missing underneath the lighthouse. Come on, man.
Pete Shea was about to make an extremely cogent and salient point about what we were talking about.
But we're letting them dance around it, and they don't want to give it. We've got one silly example of some sort of mirage of the horizon. That's what we should be explaining. Because to me that makes no
Alex.
sense.
Sorry to cut you off. We've got Borges. Is that right? How you doing?
Oh, he joined a while ago. Hey, how you doing, Borges?
Well, it's me again. I got sniped by YouTube. Wait a minute, I got sniped by YouTube. I'm going to jump out now, but it's just to tell everybody. YouTube is a sniper. He sniped me out that hangout. He's a supposed flat earther. So
it's probably a fake account.
Yeah,
it's probably
don't
fake.
trust YouTube. It's terrible.
I wouldn't trust anyone who snipes.
I got an issue with Lewis's diagram proof because I think
no, you've been brainwashed. You don't understand.
Well, the thing is, if you use a
you're just proving that you've been brainwashed.
I'd like to know if Nathan understands what I've been saying now, then why he's got this idea of there being a wall in the way and it's somehow going through it. When all it is simply that light is bent.
We are coming up on approximately 1 hour left of this broadcast. If you are new to this channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live, but most importantly, if you would like to join the debate with the page you are currently listening to on mute, simply click the link in the info box below this video to join the show and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number 1, please do not swear. If you do, you will be ejected, and if you are, please do not try to rejoin the stream using sock accounts. You will be warmly welcome back on the next stream. If you've not done so already, please share the show on social media, as it does obviously increase the live audience, which in turn increases the diversity of the panel. And one last time, if you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate.
Plugged an AV cable through my electric box.
I was brainwashed in school.
No, Rumpus, please continue with your demonstration on how free energy works.
Oh, right. Well, I was just hoping that Nathan would now understand that his idea of this being a wall in the way is subverted quite happily by the appearance of an object at H, the base of the object at H appearing at J. And there's no problem about clearing anything, providing you've got the light bending, which occurs, as I say, even over a distance of 200 meters. The Jordan Attenuk, when he was doing his test earlier this year.
To be honest, this sounds worse than when they talk fantasy.
And he was able to demonstrate that there was an inch of refraction. In other words, objects were an inch higher than they appeared to be, just simply over a distance of 200 meters. I was absolutely astonished it was that significant. over a distance of 200 meters, you're looking at things that are an inch. If you're looking horizontally, an inch harder than they should be. And that's just over 200 meters.
And at 50 miles, we're looking at things almost a quarter of a mile where they shouldn't be. It's incredible, really.
We can't see things 50 miles. Like Douglas, you cannot see in that picture, as I demonstrated with my thing down here. The left-hand side of that picture here, as I was going to point out here, matches up with the cliffs just to the left of Bala Canal.
You've actually been doing the homework. I can't believe it.
So what's the stuff to the left of that you don't have a line on?
You can't see that. So here's the picture down here. I was trying to match up.
So what's the stuff on the left?
I even identified the house that Riley.
Yeah. What's the stuff on the left then?
That's where the free energy.
Since Trumpus is doing the homework, does that mean the flat earthers are like the school teachers?
The end of the island, this yellow line here represents, this is the last bit of the island that you can see, and that matches up with this point here, and I've matched up with points.
But there's a little bit more left of that in your picture. Literally on your Google image, there's more land to the left of that.
Well, look at your picture.
Okay, Rumpus, whatever. If you think that's the case.
Not in the picture they took. I know it's there, but that doesn't. That's slightly above. I've gone up here. This is taken from a kilometre above to give the angle. But the picture that I've got down at the bottom, which is the one you can see here, which is the one that Anthony Riley took.
Get angry.
You can't see anything gone here, and I've matched up against that point here. I know you can see more of the island, but that's because I've just tried to show that.
That's what I've just said. Anyway, we've been joined by Part-Time Vegan. How you doing, Part-Time Vegan? Good to have you here, my friend.
It's good that you're joining the show. The unbiased moderator Nathan is trying to make a very important, salient comment about what we've been talking about.
Can y'all hear me?
Yes, we can.
Just to let you know, Nathan, it's me. That's me using my other account. I've got another 10 or something, so you know. But I'm ready to play the Xbox anyway. So.
Sorry, someone's asking. Is that Nathan? You're talking to me, Nathan?
No, that was me. I have a question about that diagram you showed.
Okay.
Oh, this is going to be a really cogent point. I can't wait.
Brilliant.
Which diagram? This diagram here, or the one about refraction?
The one you had about the circles and observer S.
Okay.
The one that had to do with the free energy generation and the brainwashing.
Yeah. Which shows the non-refraction case here, where you've got the lighthouse base obscured by the curvature of the Earth, and then when you have refraction, you can see it. What is at H appears at J, because your eye assumes light rays are straight, and therefore when it curves in, this is the light coming in from this at base of H, comes in at that angle. If you extend out, it then perceives what is at J, when in fact it's at H. Yes, Karen?
So let's say I'm the observer, and I guess I would be S, since I'm perpendicular to the surface.
The observer's at O. The observer's at O.
Why would the observer be at O?
Yeah, the observer's at O.
Why is that the case?
Because the observer is standing up. I mean, it's an arbitrary size up, but it's not. You'd rarely have, if you had your eyes right on the ground, you wouldn't be able to see anything any distance. So that your observer is always up at some height, and of course, in Anthony Riley's case, he's about 75 feet up or more.
See, but I mean, I think we would agree that the observer would obviously be closer to the ground, and that circle.
It's not to scale. Okay, if you want a scale diagram, okay, I can show you. I've done a scale diagram of the observation here. Let's say precisely to scale. Here is the precise to scale.
Okay.
Description of the island. So here we've got St. Bees here, and it's separated by Douglas down here at 68.4 kilometers. It's separated by 0.6 degrees. Which that's relative to the Earth.
Rumpus, you're doing more homework than them.
Rumpus is.
You don't need to do this.
Well, you do, because unfortunately you've got to put it in numbers. You've got to do it in numbers, and you've got to demonstrate absolutely clearly what's going on.
So here we've got has to elucidate.
So here we've got St. Bees, and there's Douglas. That's how much of the proportion of the Earth, and 0.61 degrees they form of a great circle of Earth. That's why I haven't put in the full circle, because obviously it's slightly at an angle. It's not going north to south, so I haven't put in the Earth in here. But that's what the ratio. That's the proportion of the Earth of that distance represents between St. Bees and Douglas. Here's a zoomed-in version, and as I was showing earlier, if you zoom into this might look like a straight line. That is actually the curvature. That is what the curvature of the Earth is at that distance. And if you zoom in, I've drawn a straight line, and you can see the difference here between the straight line version. That's that purple line you can see, and that the blue line is the surface of the Earth, and the red line is actually a straight line. That's a straight line, and you can see it gradually disappears. So this is Douglas here, and gradually see the purple line emerge underneath it because the curvature sticks it out. And of course, that's a zero height observer. And as you can see, if I go up here, the straight line, the pink line is the straight line connection, the blue line is the curvature of the Earth, and they come together, at St. Bees here. So that's the zoom I've had to do.
So the red line represents the refraction that's going
No,
on?
it's a straight line joining two, but I haven't drawn in the refracted line. That's something I was going to get round to. I haven't done that yet. That is just a straight line between 0 height at one and the other. And it just shows you how the bulge of the Earth basically is what I was trying to demonstrate here. Then I was going to draw in, when I had a moment, I was actually going to draw in the cliffs here and the height they had, and I could draw them into scale. So you can see to scale how the bulge of the Earth is relative to a straight line, but that's for a 0 height observer, remember. And these things are, we're talking this one I think is for the lighthouse that we were discussing, the Moor Gold Lighthouse, that one there. So I would have to draw in something that was beginning at 40 meters above, which I can do. Because I've got the scale factor, I can draw in a 40-meter high lighthouse here. And then for the next point was Anthony's identified a house in Balacanal. Oh, and I identified a house in Gelmona. And I was then going to stick that at 100, and that was at 112 meters, the one that he, 97 meters, the house that he thought was on the beach. I've identified it by heading using my diagram. I was able to find the house and found it 97 meters. So this thing here, this point here, which is 60 kilometers away from St. Bees, I was going to draw in a nice 97 thing, and it just appears just above the horizon, and that's because it's 97. And finally, there's Douglas down here, which is 68.4, and it's very close to sea level. And of course, you can't see it because the last thing you can see is the left-hand edge of the Isle of Man, which is 112 meters, but it appears right at the boundary to where the cliffs to the left of Balacanal. That's the last visible thing you can see on the left-hand side is at 61.8 kilometers.
Question.
Well, if you zoom all the way in, on Douglas, then you can see the diagram I have on my screen. If you screen share me, you can see my little guy riding on the water there.
Right. Okay.
I'm noticing one little funny thing, Rumpus,
So
and
my
that
question
is,
is,
there is no curve
this is over a
present
30-mile
in this
distance,
diagram
correct?
anywhere. It's all straight lines.
So
It's
what's the
hilarious that you're
It's over a
talking
30-mile
about curve,
distance,
but
correct?
But no,
all of
well,
it is
I've
straight
done in
lines.
kilometers. So this from here,
Kind of
from
telling,
here in St.
kind of
Bees,
like what I was
hold on, can I please don't
talking
interrupt me,
about,
Darwin?
you
I'm in the
know?
middle of answering. Douglas is
Single
here,
curve,
68.4.
slant.
68. Hold on, I'm answering whoever the other was
This
just
isn't an
asking.
answer. This is
Oh,
another
okay.
language to
Oh,
Just
and you
there's
can
no
ask me a
curve
question
there,
in a minute.
really.
You have to wait your turn. So
Perfunctory.
68.4 kilometers here. So what were you asking about? 35. I've got this in kilometers, unfortunately. So if
You said
you ask
35
me-
kilometers?
I've got in kilometers, yes. So it's all in kilometers. So this is 68.4 kilometers from here to here. It's 68.4 kilometers. And you can see how non-curvy the Earth is over that distance. And I just had to zoom in, as you saw, to get any sort of curve. If I showed that to you in a diagram, you'd say that was a straight line. But it isn't.
Right. But you see,
So
under
it
certain,
demonstrates
I
what
don't see any
35
curved
further
lines
refraction.
here anywhere.
So
Sorry.
over
No,
like
there's no refraction. There's no refraction in this example. I was going to put refraction in later. It's not in here at
Oh,
all. at the moment.
yeah, of course. So
but
it
would
looks
you agree that
exactly
even
like
a
this,
small bit of
but
refraction
it doesn't
would
include
affect something on the
refraction.
big
Oh,
scale? Over
Exactly.
this
35
is
kilometers?
refraction.
Exactly. I mean, you can see that the bending required
This is what
so
refraction is,
small
and this is on the straight line
Okay,
world.
see, my issue
You
with
get to
this
see a
is that
slant, exactly like
over
I
30
said.
miles.
You're
Oh, when you're interrupting again, let him
trying
finish.
to screw things over. You're trying to use
You can ask your
my
question in a minute. Let him finish his
me
question
figuring
first.
things out and
Owen,
just switching
take
around
your goddamn
words.
turn, for
You're a
Christ's sake.
fraud.
Show some manners.
You're a horrible,
What were the
horrible
guys that
fraud.
asked me?
So my thing is there'd be a variance in temperature depending on the distance, correct?
No, it depends on the height. The height goes from this way. This
Well,
is
but
height.
doesn't the
Hold on,
temperature
height,
also
let me
affect
show you
the
what height
refraction,
is.
though?
Right, that H is measured from towards the center of the Earth, so that's height.
Right.
So there's a temperature variation, temperature gradient up from there to there, and a pressure gradient and a density gradient.
But isn't there also a horizontal temperature gradient too? Like, so basically a town 30 miles from me might have a different temperature than I have, right?
Well, a town is not over a body of water.
Yeah, it makes a big difference being over water because it means it's much colder, which means the air is much denser, which means you get more refraction.
And really
so
quick,
over water,
I have
basically
entirely
temperature.
relevant
So over
point to
water,
make.
temperature doesn't really vary that much.
But
Yeah,
between
but
meals,
it's colder. No, it's colder. It's much colder than the air. So if you go to land, on
Right.
land, the air and the air above it tends to be, except on a
There's
sunny
no
day.
curve in this diagram.
On a normal day, the air temperature is not that much different from the ground because it's warmed it up. But on the Isle of Man in October, this water is much colder than the air above it, which means that you get a much bigger temperature gradient, which means you get more refraction than you would normally on a standard refraction.
Okay.
More importantly, I am also a vegan between meals.
Right, Arwen, what question did you want to ask me?
Question? No, I don't. I don't have a question.
Okay,
I
what
have a remark,
claim you
and that
make
is
then?
there is no curve here in this diagram.
Oh my god! Oh my god!
Yeah,
See, this,
you're
this,
God. Yeah, I know you're God. The
moron.
curve.
There is,
Love it.
like I just showed you.
No,
Look, okay,
look,
I'll
look,
show you.
look. See?
Jesus Christ!
It is. It's
Right,
all
I
straight
showed
lines.
you
This
here,
this
there is
line
I've
separating the
drawn
blue from the white is a
I've
straight line. The bottom is a straight line. All the lines pointing there,
that
actually in there,
look, the
all go
pink line
straight.
there.
It's all straight lines.
That pink line. This is the point. This is what flat earthers don't understand. The scale of the curve is so small over the distances that we operate in.
Yeah, sure.
So I'll tell you what. I'll put the blue curve on top. The pink
So
curve on top.
hilarious how we
so you can
always
see
fall
it.
back to the same type of systems
have
every
to-
time.
you have to let
Rumpus,
Oh, yeah.
Rumpus, is
It's
it
amazing how-
possible for us to calculate the refraction index from this? From the
Well, you
information
need to
provided?
know what the point is. You only can do that if you know what the density of air is. And the way you get the density of air, and the way you get the density of air, the way you get the density of air is you need to know three things to get the density of air. You need to know the temperature gradient, in other words, how hot it is here, T here, and you need to know the T here. So from that, the gradient, you know the difference between T1 and T2.
Right.
And then you know the temperature. Then you also need to know the pressure, and then you also need to know the absolute temperature. With those three bits of information, which you'd have to go out into the middle of the sea, because remember, you're looking through only a few meters to see. So for this picture of Anthony's, he's looking at such a low level. You're only here to see this image. It's 50 odd miles away, close, or 30 odd miles. You're looking through a tiny little few meters of air to get this image. So you need to know at that particular point in the air you're looking through what the temperature gradient is at that point there. So you need to go out there and measure it. You need to find the pressure. Well, you could just measure the density, but it's usually easier because you need to know what it's doing. If you've got the temperature, so if you know the temperature gradient, so for instance, it's normally I think we were looking at examples in the equations where it was 1 degree difference over 10 meters.
Right.
That's all you need to do to have a 1 degree change across 10 meters. So this, so if this was 10 meters, this my thing's saving, unfortunately. Hold on, let me just. If the tip of this arrow was so that to scale, of course, this you wouldn't be able to see that. I mean, 10 meters on this scale. I've got the scale up here of 10 kilometers is that distance there. So that's about a 10-kilometer arrow. But if you imagine the very tiny bit at the bottom, I could say if I could go out there with a rig and check the temperature gradient, and I knew the pressure and the temperature, I could then use the formula that Paul showed from Wikipedia page, which is what the metabunk result is. You could then say, what factor should I multiply the thing? And then you would then know from that, you would then know how curvy this curve is that I was showing up here. You would then know how curvy that curve was.
Right.
Using that information, then how bendy, how much refraction's going on. Then you could calculate. But there's a lot of measurement involved. So people have been criticizing Anthony Riley for not taking pressure measurements.
So hold on. So we need to get the starting point variables, the middle point variables, and then the ending point variables, correct?
Absolutely. So there's a lot of measurements required to do that.
And how would you get T1 exactly, and how high would you think T1 would need to be?
Well, I think it only needs to be a few meters. I think if you could get on a boat and you could go across that distance, if you could go across this 50 odd miles, 40 odd miles from here to here, and you could take all the temperature gradients and all the pressures and all the temperatures all the way along there, you'd only need to do up to about 10 meters. So you could probably reach up with a stick. And in fact, this is what George Hackenute did when he did his experiment across a frozen lake. He measured up to about 4 meters, I think, so 3 or 4 meters. You could do that, and then you could find out what the densities were. You could then predict. You could say, right, knowing all the densities of all the things it's going through, and hopefully it was uniform, because of course it's not uniform, you're also knackered. If it was all lovely and beautifully uniform, and you got those measures, you can then make a theoretical calculation of what you should see. But of course, but it does. I mean, what we actually see, that image that Anthony got from his video, does very closely correlate, but not quite to a standard refraction case. It's slightly more refraction than standard refraction. And it's not stretched or compressed.
Rompus, I do have one question for you. No, two questions.
He only has 2 questions for you. Let him get them out. It's only 2. I'm sure they're entirely relevant.
Is there any particular reason why you've not addressed any part of the assertion that I made with regards to the thin blue line and the claim that there's a mirage
I
in
did
horizon?
touch it. Sorry, yes, Anthony, I'm quite happy to talk about it. Yes, Anthony, I'm more than happy to talk about that. I got a bit distracted. I did make some comments on it.
Just a bit.
And my second question, Rumpus, is if you could just tell everybody, does light also bend up?
Yes, it does sometimes. That's what when you see on a hot, when you get a hot road and a sunshine and you get cool air, then you get those those sort of spits of sky. Yes, so of course you do. But in the case for something like this, where you've got a cold air, and this is the situations we're talking about, we haven't got a hot road. We're looking at a cold body of water.
In normal standard conditions, light bends up, and in extreme conditions, hot conditions, for example, then it can bend down and create other effects. Normal condition, light bends up, creates an
I've got some
apparent
examples
curve.
here, for instance.
That's
and
what
I've got some here. These pictures here are. This is actually extreme looming. I've got here one example, and I've got another one here, more extreme looming. But of course, the stuff that which with that paper called Amazing, but they're much more interested in the more significant.
But the point is, Rumpus, that light does bend up, right?
Sometimes it depends on the conditions. It depends on the temperature gradient. It varies. Sometimes it does. Sometimes
on what Rumpus? On what evidence are you basing your light bending down mathematics on?
Sorry, Anthony, I didn't hear you because Lewis was interrupting.
On what evidence are you basing your light bending down mathematics on?
The conditions.
Of which you know how many of them conditions?
Well, look, you said you didn't bother to listen to my explanation earlier. If you
no, answer the question. How many conditions do you know that you can account for to do your calculation?
Yeah, he clearly thinks you should already know these things.
Sorry, I'm not. The standard cases I demonstrated with. If you just consider a ball with several layers of refracting material that increases as you go down, as happens with the atmosphere, because the density increases as you get closer to the surface of the Earth, you get these sort of effective notches. And if you had to consider it as a solid, but with a continuous thing like the atmosphere, which has refraction, the refractive, but where it's denser, the light is slowed down more. Therefore, it's slowed down near the surface of the Earth and becomes less dense higher up, therefore it refracts less. You get a natural curve. The natural standard curve, and that standard atmosphere, the standard way surveyors know, is that you get a natural. That's the thing. Actually, I don't think you understand.
You haven't answered my question.
So, because according to your theory, refraction adds to the curve.
Hold on, I've got an important point to make here.
Then it doesn't actually counter it. So why can you then see things so far away? That doesn't match up with the shape of the curve.
Very important point to Anthony. Do you understand that by light curving down, things move up? You do understand that's what's happening. In this diagram here, light is curving down, and that makes them appear to move up. Whereas if they were the light was curving up,
is only bending down. Rumpus, light is only bending down if you've got the calculations and the data to be able to prove that it is. On what data or figures are you inputting into your maths to conclude that the light is bending down? Because I don't have any data, and I know for a fact you don't have any data. So how have you come to the conclusion that the light is bending down?
The standard case as I described up here, the standard atmospheric case is for light to bend down. Just as Jordan Nathan measured it when he did his tests, because the light bends down, things appear to move up. That is the normal, average, standard case.
Are we in a standard situation?
Based on bear in mind, Rumpus, that we know that light bends up as well because Soundly's proved it with his Pontchartrain. We know that light also bends up. Now, what I assert to you is that you have no data whatsoever to do any form of maths on, and you should not be simply showing it bending down when we all know it also bends up.
So if you share my screen, Nathan, I can explain this a little bit more simply than what Loomis is doing.
I think we all need to take a moment to
I will
consider
do, Brenda.
that Anthony
We've
Riley
also been
is
joined
both
by
without
Curve
any
Water.
data at
How you
all
doing,
and an
Curve Water?
expert on
Good to have you
everything.
Yeah, here's
Hold on just 1 second, Brenda. I just want to get 2 seconds of speech from Curve Water.
Hey, Curved.
Hello.
I don't think his mic's working, so you carry on, Brenda. I think he'll drop and rejoin.
Here's the difference. Okay, if you're sharing, here's the difference between a regular mirage and a looming artifact. It bends down when the air is close to the ground is warm and up above it's cooler. and when it's warm up above and cool below. That's how.
Now, to be honest, Brenda, you've done more there than what I.
Come on.
This is what I expected Rumpus to do. I expected Rumpus to demonstrate what we were talking about.
This is what Anthony expected.
Stop trying to discredit everyone, man.
Yes, they need cartoons. They need cartoons. Yes, I know that.
Come on, Brenda, please continue. It was good. Please.
This is what Anthony expected because he's an expert on everything without any data.
Yeah, this is pretty simple. Warm air close to the ground, cool air above. It bends in the above in this image. Cool air close to the water, warm air above. You get the looming mirage like this.
That's actually
That's
actually a special case you've got. That's not just basic looming. You've got an inverted image as well. So that's a special form of looming. You've got an very extreme form of looming you're describing there.
Well, that is what looming is.
And I'd like to know why it was that Rumpus didn't tell everybody about this.
Is much nearer the standard than is being described there by Brenda. Brenda's is quite an extreme case there, and that's why it's got an inverted superior image on it.
Yeah, but Rumpus, would you agree that it's based on the evidence that we were looking at? It's far more applicable than what you're talking about because you don't know any of the values to make it show that it's bending down. Whereas Brenda's shown that it can go either way.
Anthony knows exactly what's applicable because he's an expert. I don't think you've.
Hi, Curved. How you doing? Good to have you here.
I came in for this one purpose. Anthony needs to understand what he is citing from Soundly's video, where he's saying the light is bending up. Riley, you're talking about the position of the lights in the distance, the physical lights. They appear to be bent up in the image. However, that is due to the light bending down. Do you understand this?
I just want to know why Rumpus didn't talk to us about the light bending up and down, and it's only about the light bending down when he's got no data for it.
Of course he understands. He's an expert.
Downley was not showing light bending up when those lights that he strapped to the pilings were shown to kind of straighten out. That is light bending down.
Thanks, Curved.
Why is it
So,
always
Rumpus.
the case with you flurpers that you don't know up from down?
And I've got this curved on the diagram here where I was showing again how the thing raises up as the light bends down. So you get an opposite effect when the light is curved, is saying, and he made a very good point that highlighted this situation 2 days ago. When the light is bending down, it lifts the thing up. And when the light bends up, the things move down. They go in the opposite direction to which way the light is bent. As you can see from my diagram here, the light bend down, and therefore it lifts the image up, as Curve said, and he pointed out 2 days ago.
So why is it that you didn't talk about this and you only talked about light going down around the curve?
In your field of view.
Yeah, Anthony Riley already understands this, guys. I don't think you've considered the magnitude of subjects that he's an expert on.
Of course he does.
I just wonder why it took a cartoon from Brenda to get Rumpus back on track.
I know, it's because Riley's such an expert.
So we have approximately 30 minutes left on this live stream. Hope you're all enjoying the debate thus far. If you are, toss me a buck or two in the super chat, which runs along these shows while it's live. If you're new to the channel, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to join the debate, there is a link in the info box below this video. With the page you are currently listening to muted, simply click that link to join the show and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number 1, please don't swear. If you do, you'll be ejected. And if you are, please do not try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. As I say, we have about 30 minutes left on this stream. So one last time, if you've not shared already, please share on social media. And if you've not subscribed, subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate.
Looming. It doesn't have to be. That's what standard refraction does for you. Standard. And we've got slightly non-standard case in Anthony's video. Slightly non-standard, slightly more looming than we'd expect in the standard case, but only slightly. And then you have, and that's caused by the light curving down below the horizontal, which lifts it up.
But the thing is, though, Rumpus, you haven't got any evidence to support your assertion, whereas I'm basing my assertion on the evidence. So why are you calculating for stuff that you have no evidence of?
We should really put a lot of attention on that.
You tried to make
Thanks,
a point,
Lou.
Anthony.
Really, really useful. Do you want to try that again, Anthony?
I know it was really. It's important that everybody understand exactly how smart you guys are.
Is Riley
Rumpus,
trying to invoke?
I based my assertions on the evidence that was
I
available.
like your new role.
That you
Yeah.
believe
Keep doing it.
negligible, and that's the cause of all of that magic mirror water that's obstructing the land below the lighthouse.
Thank
the
you,
magic
Gurf.
mirror is due to the negligible refraction.
Yeah, what happened?
Refraction.
Yep.
Sack of shit.
Standard refraction. That's what that causes that.
Oh, no swearing, Curve. No swearing. That's really offensive. That's really dangerous.
That's
It's against the
not
rules.
swearing. If I said other things, that would be swearing.
Yeah, he definitely
But
did.
that's not
I
swearing.
don't hear any swearing.
I hear
okay.
that all the time.
I didn't. Oh, okay. You didn't swear.
Yeah, if that's bad, let me know. I'll refrain. But I hear that all the time.
Okay, so back to my question, Rumpus.
Yeah, we need- let's
I
get
asked.
back-
I made an assertion based on the evidence that we could see, but you've made an awful lot of maths on evidence that you have nothing
So,
of,
he's
and you've
done
only
lots of
shown
maths.
half
Right,
the
you keep on
story. You've
saying
only
that,
shown
but
it where the
Anthony,
light
I'm
bends
talking about
down.
the standard atmosphere. This is what the
Yeah, but
atmosphere
you've
does
only
by
shown it with the
default.
light bending down, but we know that light can also bend up, and you haven't shown that, have you?
Yeah, we know that light
Anthony,
can bend up.
do you
Yeah.
understand that in the standard case that light will behave as I've drawn it here? The standard case of light in normal
But
conditions.
you haven't got any evidence to apply that,
understand that?
have you, Rumpus?
How can you claim to know where things go? Light's bending up and down and all around, spiraling.
Okay,
in
we'll
and
get
out,
we'll get back
flying
to the limited
universe.
evidence
But-
Rumpus has to
but-
apply
Anthony,
once
do you
I've just
understand
introduced Paper.
that
Is he
in the
still
normal
here? Are you
case-
still here, Paper?
Hold
Is
on,
he
hold
gone?
on.
Have we lost Paper Explanator before he's even said hello? Wow.
Oh man, we lost Paper Explanator. That. ooh.
So Anthony, do you understand in
Oh,
the
it's
normal
so
atmospheric
terrible.
case,
So
where with the
sad.
standard atmosphere you get bending down? That's what happens normally.
Are you
That is
referring
the
to the
normal
apparent
default
radius and the geometric arc mathematics that are calculated
Yeah, the
for? Is that what
geometric
you're
arc
referring to?
mathematics. Yeah, what a lot of
What is
wonderful
that?
terms.
Riley, can you
Anthony's such
explain
an
to
expert.
us? What are geometric arc mathematics? What are you invoking here?
I'm applying the rules of standard refraction according to Mick West on his
he's
Metabunk
applying
website.
the
How are you
rules.
doing that?
He's
But if you
applying the
were
rules.
Anthony, you would get a
How
curve
do you-
like this.
okay.
If you
How do
apply
you-
the standard refraction mathematics, you would get a curve as I've drawn in this diagram, and this lighthouse at below the thing would appear at J. This is not to
Agreed.
scale, but this demonstrates the
I
principle.
agree. So we agree
guys
that
fail to
standard
realize-
refraction makes the light bend down.
You guys fail
Yes.
to realize how
You
good
understand it bend
Anthony
down?
is
Brilliant.
at
Do you understand that bending down also means it lifts the object up? Do you understand that?
Of course I
Anthony
understand
is
that,
really
but
good
I'm
at
asking
reading
you,
Google
we
Earth.
know that
Brilliant.
light
Excellent.
bends
Making
up.
progress.
So why are you not telling us that light can also bend up and you need to know the data and that you don't have the data, therefore your conclusion is
Now, I'll
totally based on
explain for the
conjecture?
10th time, Anthony, because you are outside on a not that abnormal day, and you were doing it over water, which is a constant medium. Therefore, it behaves in a standard, close to standard way, because you weren't in an exceptional day. It wasn't like it was 30 degrees C or anything, or 50 degrees C. You were out there on a sort of 10, 15 degrees C day. The water's going to be a bit colder than usual. You were close to a standard situation. So I can use something close to the standard refraction that we would expect here. And we get and we do, because we get the results that we see are very close to the standard results. Just slightly more.
Rumpus,
just slightly.
I don't think you're understanding my point.
Well,
Yeah, you're
I'll
not
ask it again for the
understanding
final
exactly how
time, and then
good
I'll step
Anthony
out because
is
it's not
at
going to go
reading
in. If you
numbers
don't get
off
it
of
this
Google
time, you're
Earth.
clearly not
Hold
going
on,
to get
let
it.
us
So I'll
explain,
ask it the
Abigail.
final time, and perhaps you can give us the answer based on that
Yeah,
one
maybe
question.
this time we
We
can give
know-
an answer to Anthony, the expert.
We
who
know
can
that
read-
light bends up as well as down, and we
Not
know
in
that
this
you don't have any
conditions.
data
But
on
Anthony,
which to
not
base
in
your
these
assertion that the
conditions,
light's
not in these
bending down.
conditions.
So why
Under
are you
what
not showing
conditions
light
does light
bending
bend
up
up,
as
Anthony?
well and concluding that you don't have the data and therefore it can go either way?
Under
I
what
do have the
conditions
data.
does
I
light
have the
bend
weather
up,
data.
Anthony?
I know where you were, and I know the weather where you were, and therefore I know it's close to standard, and it behaves like it. The evidence we see in your photographs agree that it's close to standard. The standard case is you get a small amount of looming. In your case, you had what I think, depending on the height of your observer, we might have a slightly more looming than usual. So
Your
I could
video
see
Yeah, but
the
there's four
weather.
things that you need to know, Rumpus, and
I
temperature
do
is
know.
only
I can
one.
see your day. I can see the weather in this where you were. I could see it wasn't
Yes,
50
but
degrees
you don't
C.
have the data. You're conjecting that that's what you think.
I
However,
know
you do
it's
not
close
have
to standard, Anthony.
you do not have the
I know the
geopotential
weather
altitude, the vertical
I'm-
pressure
I'm
variation,
conjecting.
and you
I'm
don't have the
conjecturing.
ideal gas law in molar form. So you can't do any calculations, Rumpus. And again,
You didn't think
you're only
about-
showing
you're
it
just
bending down, but we
conjecting.
know that
Why
light
is he
bends.
bringing dentistry into this?
Yeah, you didn't
You're
think
just
about
conjecting, Lewis, you're just conjecting.
I know it's just conjecting, and I think we should have all realized how good Nathan and Anthony are at reading Google Earth.
Anthony, your day was not abnormal. Therefore, your day is very close to a standard refraction case.
When asked
How do
about
you
the
know
weather,
that?
why did you blurt out that it was about 30 degrees,
Yeah, that was
Anthony?
ridiculous. That was almost constitutes a lie. I'm reluctant to call people liars. I mean, either you
The
have
high,
no idea what temperature it is.
the high for St. B's was like 13.4 for the month.
In October,
and you came up with 30.
I went there twice
Yeah,
in a short period of time. I forgot which time I took the
outrageous.
evidence. It's not a big deal.
How oblivious are you, Raleigh?
Every
I'm really reluctant. I'm really reluctant to call flat earthers liars because
Yes,
I know
so am I.
how honorable and trustworthy they are.
They're the most highly honorable and expert people in
So,
the
so Anthony,
entire
all I've
world.
done, I know that your day around the Isle of Man does not have exceptional conditions. You were over water, which means that's pretty uniform.
You don't know
So
that
I
though,
know
do you,
I'm
Rumpus?
very
You're
close.
assuming
What
that.
you see to get the light to do what you're talking about, which is going to be light going up. You're talking about the sort of situation you would see on a hot road on a sunny day with cold air, where you get strange mirages. That's nothing to do
Oh,
with
you
your
mean
case.
you mean
Why
like
are you
Soundly
talking
got on
You
his
were looking
Pontchartrain stuff
across
where he
Lake
put his 8
Michigan
lamps on
at
his 8
Chicago and
things?
saw the city inverted upside down on the top of the
Is that
mirage.
what you're referring to, Rumpus? Are you referring to where light bends up in Soundly's video where he's got 8 lamps on 8 stands?
I haven't seen
Because we can
Light
see that
bending
there.
down, you moron.
Yeah, exactly.
How
You're
many
getting it wrong
times
again,
does that
aren't
have
you,
to be
Anthony?
said to
You
you?
said you understood. You don't. You're getting it wrong again. Light
No,
bending down
Rumpus.
means that things move up.
Soundly has shown that light
Don't
bends up and
confuse
down
the
at the same
lights,
time.
the
Little bit up,
objects
little bit
with
down, little
the
bit up,
light
little bit down.
bending.
It's a continuous
The
variable,
objects are
Rumpus.
moved up
What you're
because
showing
the light
is a
bending
grade.
down.
It's an
Look,
arc.
Anthony is such an expert. Anthony is such an expert that if he thinks words, they are by default true, so he should say them.
Hold on, Lewis. Nathan needs to introduce me.
Oh, I'm sorry. Nathan, you can go ahead and introduce Steve at any moment.
Silence, please.
Right now.
I'll introduce myself. Hello, Steve. How are you doing? Oh, I'm doing great. Thank you very much. How are you, Nathan?
Oh, thank you
Oh,
so
I'm
much
doing
for coming.
great. Thank you
Pleasure to
so
have
much
you,
for
Steve.
coming. My name's Nathan
Welcome to
Oakley.
the show. Did you
Welcome to
share
the
the show and hit the super like?
Don't forget to hit that super like smash button.
Yep, we need to make sure that happens.
Guys.
as well.
Okay, so we were just I just overheard Anthony Riley saying that he couldn't, he can't show the date and time and all that stuff where he was, when he could just show us the properties of the raw video files that he has.
You wouldn't believe them anyway, because who was it now? It was
Okay, but you
Jeremy
said
that
you
said he
could-
wouldn't
but
accept
you
them
didn't-
anyway,
you
so there
didn't
would be
have
no
the
point.
ability to prove it.
So there's no
Was he
point in you doing
shooting
that.
in RAW?
The
Did you
Ranny's
shoot that in
video.
RAW?
All his video files, they all have names which appear to be created from a camera. So he could just show us
I could
the
be right.
properties
Raw
of those.
images, though. Is this
Well, the
raw
video
format?
files. I don't know.
Should we accept non-raw format photos?
Well, it will give us a time.
They wouldn't
and
be
date.
accepted anyway. Jeremy said he wouldn't accept them, so
It-
there would be
it'll
no
give us
point in
the
doing
time
that.
and
And I
date.
see
So
this as a
obviously,
distraction
if
from
they
the
were
point, to
created
be
at
honest.
midnight, then
Isn't
they're
this
obviously wrong.
Riley's own standard? I thought Riley only accepted raw. Is that not true, Riley? Am I misrepresenting you now?
No,
based
no
on
protection
rumors
for
I've heard?
Anthony.
No, for
Only
once,
raw.
Curved, you seem to have it reasonably correct. That's exactly my position.
Reasonably correct is
You don't
just
think-
barely correct in Anthony's
So
terms.
why are you submitting other than raw images as evidence, Riley?
Because Ranty found
Why
out
are
that
you
it didn't
such a
match the
fat
model.
hypocrite?
Well, I mean, you can just show us the properties, the details of the
Yeah,
files.
you're right, I could. You're right, I could.
You could.
Yeah, you could do that.
I could.
You could do
Well,
that.
you
but
couldn't.
That would validate him, and he already knows he's right. So why should he have to prove when he already knows he's right?
He
It
could
wouldn't be
just go
accepted if I
choke on
did
that
show it.
purple
That's
dildo
basically
he
the
loves
problem.
so much.
So
I mean,
can we go back to
Anthony,
Rumpus, please?
It's a pity for all
I'd
your
like to know
expertise
why
and all
Rumpus
these
is only
skills that
showing
you
half the story and
understand
not
and
admitting or
brainwashed.
accepting that he's got no evidence on which he can base it.
Nathan, if you can just go ahead and screen share me, I can provide a lot of evidence to the brainwashing you've all suffered from.
Why do you people love paying electric bills? Let Lewis show you the way.
Yes, thank you, Curve. Thank you. Now I've got a picture on my screen. If you can just go ahead and screen share. If you can just go ahead and screen share.
I'll present you.
Thank you. I don't think you've
Oh, wait a
considered
minute.
that. I don't think you've considered that light curves up as well as down. It curves up.
Nathan seems to have neglected to give me moderator controls.
No.
What?
I can't
It's
present
curved.
you, Lewis. I'm sorry.
I think of all the
can't.
people that should get mod controls, it should be curved. Come on.
Because I'm as moderate as they come.
I thought we were saying that light only curves
I
down.
should have moderate.
But
I
it
should
curves
have
up too. Oh.
I think I should get moderator controls. Nathan. That'd be good as well.
Do
We all get
magnets
Is
moderator.
Rompus still
curve
in?
up
Is he
and
still
down?
here?
Do magnets curve up and down?
So
I don't
Riley,
think
you
he
don't
is.
you
It
don't
looks like
need
he's
to
gone.
produce this evidence of the time and date that you took the videos at, but
Correct.
it would kind of help, like
No, it wouldn't.
debunking
It wouldn't help
the
at
whole
all.
conspiracy.
It wouldn't
that
help in any
Jeremy's
way,
put out
sense, or
there.
form.
Yeah, it would. It
Is
would
it-
definitely address. It would completely put
No, no,
a
really,
giant
it
hole
wouldn't,
in
and I won't be
Jeremy's,
doing it because you wouldn't
conspiracy.
accept it even if it supported me. It's just a
Well,
distraction.
sure,
Where's
sure,
Rumpus?
sure we would. No, you misunderstand. Do you understand the conspiracy that's been put against you?
Yeah, totally understand it, and it's
What
a
is it?
distraction,
What is it?
and I want to know why Rumpus is only showing half the story.
No. What is it?
Is
A
Rumpus still
conspiracy.
here, or is he gone?
What is the conspiracy that has been drawn against you by Gem Panda? What is it?
He thinks that I was on a golf course, and he thinks that a map from the Girl Guides was credible
You're already wrong.
to say
That's
that
not
I
what it
was
is.
somewhere else.
Nobody thinks that Gem said you were on a golf course.
That's
Why
what
are
his
you
video
so
showed, though, isn't it?
incompetent, Riley?
Yeah, you can't even tell. Did you even watch his whole video?
Yeah.
Of course I did. I left a
Why do
massive
you have such
comprehensive
an
comment
inability
underneath
to
it.
hear
Just
what
skip-
people say?
Skip to the last 5 minutes, okay? Just you don't have to watch the whole thing. Just skip to the last 5 minutes. He summarizes very well. He makes good videos.
Shout out to Gem Panda for the
Anthony.
advert. Thanks, Gem Panda.
Anthony.
It's Gem Panda. I'm gonna
No, shout out
overpronounce
Gem
all the
Panda.
G's.
Gem Panda 2012.
Anthony, can
Sub
I
his
ask you
channel,
something?
Like his
Not
videos,
really.
share his videos.
I don't know what relevance it'd have. I want to address Rumpus. That's the only reason why
No,
I'm here.
Anthony, can I just ask you something real quick?
Go.
Because
go.
You know how you said that you had no intention of taking that video of Isle of Man / Ireland, but you know you just decided to do it anyway, not expecting to get anything, and you expect us to believe that by the sheerest of accidents that you found the one place in Google Earth where Google got it wrong, and then
No.
after that,
No,
Google
that's
obviously
not my
are
position
watching,
at all.
and then they changed Google Earth just for you and
No,
Ranty.
that isn't my position at all. I think you might have
Well,
perhaps
that's
misunderstood what
whose
my position is.
it? Because yesterday you were saying, you and Ranty were saying, oh no, Google Earth have changed it now, so it fits the globe model.
What did
No,
you
I,
do
I
to
think
change
perhaps you've
the
misunderstood my position. Perhaps you've made a
What
mistake.
was your position then? What was your? No, am I misunderstanding the
Google Earth
position?
changed it so it
is
matches 35 feet.
Yeah, that's exactly what you said.
Anthony,
I did
yesterday
say
you
that
said
bit,
that you
but your
wanted them
premise,
to
the
continue
whole
on
part
with
of the
that,
first
but they
sentence
couldn't
that you
because
said
other
was
people
completely
came
wrong.
on and just started destroying them.
We wanted to talk about it, and you said, "No, Google have changed it now." So you know, end
Yeah,
of story.
that's
Let's
the only bit of your sentence that you
move
got
on.
correct. The rest of it you got
It was
wrong.
all a charade because Gem Panda obliterated it.
Yeah,
No,
Gem
you-
Panda
you have it
completely
open.
got all of it wrong, and I've left a message
You
on the
have-
video comprehensively addressing at least
So are you
4 maybe
trying
5
to
points.
tell me that you and Ranty did not say that last night? Because I think everyone here knows that you did.
All right, so Anthony, you
Hang on. Is there a new video out that I've not seen, or am I on about the part 1?
have you seen it? Have you
Doesn't
seen the
matter
whole
what
thing?
video you're talking about.
So far,
I've seen
you
part
think
1.
that Gem
Are we
Panda-
talking
hang
about
on, hang
another
on,
part
hang
2?
on. I just want you to corroborate what I'm about to say. So far, you think that Gem Panda is accusing you of being on the golf course. Is that what you think?
Are we? Can I just ask what are we addressing part 1 of the video, or is there part 2 out already?
Yes, we are. Is that what you think? Do you think Gem Panda is accusing you of being on the golf course? Is that what you think he's doing?
Gem Panda's accused me of faking the evidence.
In what way?
Oh yes.
Because he said, did you not watch his video? He actually
Yes,
said
I
the
did.
words fake
Yes,
the
I
evidence.
did. And how does he accuse you of being fake in the evidence? What does he
Because he
accuse
said that
you
the
of doing
beach. He said
to
there were
fake
4
the
points he
evidence?
made. There were 4
Right, and
points he made.
what
One
were
was
they?
that I was on an elevation of 75 feet because he got a Girl Guides map saying that I was. The second the second allegation was that the oil platform had changed its position because the tide was coming in and he hadn't realised. The third
That's
one was
not
that
what
the
he,
beach
that's
was
not what he said in
drier
the
than
video,
it.
but go on.
The third one was that the beach was drier on a few hours later, and he hadn't realised that that's because the tide had gone out and stayed out a bit longer,
That's
so it had
not what he
dried.
said either. Go on.
And the fourth one, I forget what the fourth one was, but his
Well, it
words
doesn't
were
matter 'cause
Riley
he
fake.
forgot what
Yeah,
the
he's getting it
first
all
two
wrong.
were.
Yeah, you literally got.
So I'm
3
obviously
out of 4
referring
of
to a
them
different
wrong.
video than
You're
what
at
you guys
best
are, because
case,
that's
if you get the
exactly what
next
his
one right,
points
you're
were.
at 25%.
Why do you hate golfers? What do you have against golfers, Riley? Why are you so hateful towards people on golf
Anthony
courses?
Riley, the genius flat earther from the internet, everyone.
Lewis, are you referring to his part 1 video or not?
Are you
How
too
many times
fat
do I
to
have to tell
golf,
you
Riley?
yes? What other videos has he made so far?
Right. So
Riley's
if you've read my comment underneath his video, all of the points that you've brought up in his video have been addressed comprehensively.
See you guys
What
later.
bit
It's
did I
been
miss?
wonderful being here. Keep in mind that light bends up and down.
Shit. What about
So you
magnets?
can't answer the question, can you not?
Magnets bend up and down.
But are we ever going to get back to this missing curvature? Because otherwise Rick's going to kill me. I'm serious.
It's like 138 feet missing from the photo or something like that. Riley is
Well, to be
invoking
fair, Alex, I have
negligible
already addressed it
refraction.
specifically, and Rumpus has not even addressed it in response at all,
It
other
did
than
get addressed.
to acknowledge that I'd said something.
Alex, it did get
Did it?
addressed. Alex.
Or with the Mirage thing, and then we just moved on. Like
The magic
Well, yeah,
mirror
Rumpus
due
just
to
moved on and
negligible
started looking at
refraction.
pictures of the
That's it,
Chicago
that's good
skyline or
enough.
something, and I said to him,
But
well, why have we now moved
Riley
on to
says-
pictures of the
Riley
Chicago
says it's
skyline?
negligible. Why would he invoke refraction that he claims is negligible? That
Alex,
doesn't sound honest.
Lewis is
Alex,
back.
it did get addressed. It did get addressed, Alex. Alex, it did get addressed.
I'm sorry, Nathan. Sorry, you're right.
We missed
That
you. We
doesn't
missed you,
sound
Lou.
honest.
Doesn't matter how
You
much
managed to
curvature
stay
is.
away for about. It was measured in seconds.
He couldn't even stay away.
Yeah, that's
You had to
not
go.
honest. He believes the refraction to be negligible, yet he invokes it to create this magic mirror to cover for the fact that all of that land is hidden. That should
All right,
be
we've
So
only
is
got about
Rumpus in
2
chat still, or is he
minutes
gone?
left in the show.
Are we transitioning to pictures yet? Or are we still being broadcast?
Yeah, we're still being broadcast, mate.
I noticed earlier a lot of this was being stomped over by silly pictures and stuff. We couldn't even see the demonstrations on
So
screen or anything.
where are the where's the
still hear us,
property of the video files? Where's that?
Still haven't given
Why
us
what,
that.
sorry?
Must have faked it by now, Riley. Come on. Giving you ages to do it.
He doesn't need to fake it. He could just show us the real properties.
We're thinking about it.
You're right, I
And
could show it,
negligible
but I'm not going to show it
refraction
because it's
create
not
a
going to
magic
benefit
mirror.
anything.
I have evidence here, if you can screen share.
I mean, Riley actually
What
thinks
is it
that
evidence
water
for?
on the other side of the horizon that's angled away from us
Free energy. That's
is
what it is.
reflecting up into what? Reflecting into
evidence.
what? To be reflected back to the camera. How does that work, Riley? You're a genius.
Anthony,
Can you
about that
please
Google
explain?
Earth thing. See Gem Panda takes last night's hangout and shows exactly what you and Manti said about Google changing Google Earth because you get too close to the truth. I mean,
Yeah,
you
Google
did-
Earth have
did-
changed it. Exactly changed it. What Ranty said, I
crazy
agree
here,
with.
or
They've changed it
Did
completely.
he and Ranty say that or not? He didn't. He did. He said that.
That's what I heard. That's what I
He
heard.
literally
I
just
might-
agreed
I
with
might
you.
have
He
misheard.
literally just agreed with you, and you talked over him.
Say that. I think you're not.
I've
You're not
agreed with you
giving
all the
enough
time.
credit to the big boss man.
You're making it out as though I've got
By
some
the way,
kind of
I
disagreement
can-
with
I
you
can
for some
finally
reason, and that
settle-
I'm
I
making
can-
some kind of lie out of it. I've agreed with you at all points, Chris.
Yeah, he's agreed with us on all points, Chris.
We don't know the time.
I
of the
agree.
case.
I agree. No, it isn't. I agree. No, it isn't. That's your war cry, Anthony.
But that isn't what I said, though, Chris. Again, you're misrepresenting what I said. I agree.
Yeah, you're
No,
with
I'm
you,
not
Chris.
misrepresenting. You're
misrepresenting.
misrepresenting.
Yesterday we said, right, are we talking about this Isle of Man thing after
Aye.
Gem Panda's video, and you says no.
I can find
Google
I
have
can-
changed. Google said Google have, so we can't
Yes,
talk about
Chris,
it. We need to
that
move
is
on.
exactly what was said, and I
Highly
stand by the
convenient.
position, and I
That's
haven't
exactly
changed my
what
position,
he
and
said.
I agree with you. That's what was said.
Do you remember
I'm
when you did the
presenting you, Brenda.
observations?
You're
Anthony?
being
Do
presented.
you remember?
Good.
Remember what day that was?
Yesterday.
Go
you know
ahead,
what the
Brenda.
weather was like.
You know, I can settle this
There's
whole
some very
question.
simple evidence that you could provide, which would show us the
Yeah,
time and date.
When did you take this video, Riley? Because you said it was in October, and you said it was 5 months ago.
I didn't
Which
say it
is
was
it?
5 months ago. Somebody else has said that. I said that, and that's not true. I said it was at the
How
end of
have you said
October.
you can't remember if it was summer or winter? 5 months.
So tell us what is
I
it?
said it was at the end of October, and I said it was months ago.
If you share the properties of the videos,
June?
that'll be like evidence right there.
I think that was one of the claims that Jem made. Sorry, I think Jem claimed that you had gone back after one of those early hangouts and actually retook the footage.
Yeah, let's just go over.
Yes, he
all
does
this.
claim that. Yes, he does.
So we could
And I
just
tell you what
look
I
at the properties of the files, and we can
Yeah,
see
you're right.
when
I
they were
could do
taken.
that, but I'm not prepared to do that because it
Why are you
won't
not
prove
prepared to
anything.
do that, Anthony?
He's not prepared to do that.
You don't know when you took it, Anthony, do you?
You don't
know
even
when you took it?
understand
You don't
that
need to
light
know, but what I
bends
can show
up
you.
as well as
I'm
down.
telling you how you can check it.
I know.
So
I hear what you're saying, and I'm not prepared to do it. Do you understand what no means?
No, you said you're not prepared. You didn't say no.
I said
So
no.
why are you not
I'm
prepared?
not prepared to do that. It won't prove anything.
He's not
Yes, it
prepared.
will.
He's
It will
not
tell us
prepared.
what the time was, what the day was, and we can check the weather at St. Bees on that day, and also in Ireland and the Isle of Man. We can
No
do
need
that.
to check. Riley already told us it was 30 degrees.
It's probably 33 degrees. But I want to
Could have
know.
been 33 degrees, even though the high temp was 13.4 in St. Bees for that month. That's what the records show. But yet Riley recalls it being about 30 degrees.
Look,
How incompetent are you, Riley?
Does he mean Fahrenheit or centigrade?
What's the highest piece of land on St. Bees?
It's way off
He could have
either
like
way.
took the photo of the caravans and then walked up to the highest point.
I think
way
what
off
no
either way.
his girlfriend took the picture of the caravans, and I think what he actually did was at least the one from the beach looking up at him. I think what Anthony did was he didn't want to go down to the beach because it'd be a lot of work to get back up. It's like a mile walk. Did you hear how he was wheezing as he moved like 15 meters down to the lower level?
I don't think it's fair to mock him for him being so out of shape. He is fat, that's to be expected.
Yeah,
I'm
Lewis,
just
it's
saying-
disability, Lewis.
I'm just
Is this really
saying
the
he
best
could have
you
asked his
guys have got?
girlfriend to turn around
Really?
with her camera.
I'm a bit disappointed,
take
guys.
the
Is this
same
the best you've got?
observation from the
Nothing but ad hom for Anthony Riley. Wow. Okay.
I mean,
hey.
Okay.
Can we
There's
settle
no-
this?
no
Can
problem.
we settle this question? Can we settle this whole question?
Finally, you screen share me.
And it's not an ad hom. It's just an insult. It's not a logical argument. It's no logical fallacy. It's
We just
just
settle this whole flat
That's
Earth
true.
question. Can we just settle it? Just right
You guys
now.
need to learn what
Please.
Yeah, I agree. The Earth's not flat.
Please.
Why are we still debating this?
Here's the picture of the Earth. It's a single photo. It's
So
not a
the Isle of Man debate is over.
when did you take
until
this,
Anthony
Brenda?
Riley shows
Not
us
a amazing.
the
It's not
details.
CGI.
When did you take this,
and the time and
Brenda?
date.
When did you
Okay,
take this
I'll read
photo?
it.
It's a single photo. It's
When
a
did you
single
take
photo
it?
of the Earth.
When
90
did you take
meters
it?
is
It's
the
a single
highest.
photo of the Earth. It's not composite, not
When
CGI.
did you take it? When did you
The
take
Earth
it?
is-
Brenda, when did you take the photo?
This is a photograph of the Earth taken by a Russian satellite.
Oh, you didn't take it.
It's a single. It's a single. Yeah, that doesn't matter.
Oh, that's
It
a
isn't
pity.
important.
Is that the Russian satellite that's similar to the Himalaya 8?
Oh,
Boom.
we can't present
Ding,
photos
ding, Brenda, you
somebody
didn't
else
take
took?
that photo.
So it's
Ding,
game over.
ding.
Game over for flat
ding,
Earth. Game
ding.
over.
Ding, ding, aye, ding, ding.
Game over.
Do you know what the flat Earth really boils down to? It really boils down to just like
Game
children
over.
going, but why?
So
but why?
Nathan no
but why,
longer
but why?"
accepts
This is the whole
Riley's
debate.
video because he did not record it.
With a
Did
new
you
guest,
take Nathan?
Nathan.
Did you
Is that
take
correct?
the? Did you take the Nathan's video? Riley's video, Nathan.
It is actually possible for me to travel to that
You accept
location
that?
and take a video, though,
You
isn't
Were
it?
you there? Were you there?
Don't do it.
Can you
Otherwise it doesn't
just?
exist.
Sorry, that was.
Did
I'm
you
getting,
take it?
getting.
I can't accept. I can't accept
yeah, I'm
Riley's video
getting
'cause I
muted in
didn't
the
take
hangout.
Hey,
But I
don't
didn't
cry about it, Nathan. Don't cry about getting muted.
Yeah,
It happens to
okay.
everyone.
Thanks,
Who
Lou.
did that?
6ix9ine did that.
Oh,
Yeah.
We need to know what the day
See,
was. We need to know what the
everyone gets
time
muted.
was.
No, you don't.
We do.
Ow.
Nathan, I
Brenda,
think
could you
someone
just-
joined.
Brenda,
6ix9ine
could
is
you
a
just
sniper.
repeat your
He'll
position
snipe
with
us
what you
all.
were
I
interrupted?
think
Like you
we
really do.
Oh.
Anthony.
We should
No,
have.
you don't. But
I thought you were going to introduce 6ix9ine.
well, he muted me. That's awfully rude.
Yeah. You know, it's really simple. We have photographs of the entire Earth. It's a single photograph, not CGI. It's absolute proof that the Earth is a ball. Game over for flat Earth.
Yeah, so I can't verify that, though, can I? I can't go out and take that photo. Can I, Brenda? I mean, I can go to St. Bees quite easily. And as Jem's example goes, Fiji. I can go to Fiji too.
St. Bees.
But I can't really go out and take that photo.
I'm accepting that Riley did it.
I stand on that clip.
You're just accepting. And Riley, you know, he could be lying.
But I could easily go to St. Bees, though, couldn't I? I can't go to space and take that picture that Brenda showed. None of us can.
Yeah.
None of us can.
I mean, just think about this. Just think about this. More people in the world think that space photos are real than think that Anthony's photos are real. Just think about that.
After all, the
Amazing how
photograph
stupid
I
people are.
showed was
Yeah,
not a composite, and the photograph that Ranty and Anthony showed is a composite. Case closed.
How did you know it wasn't a composite?
True.
Ding ding.
Boom.
Well,
Ding,
the
ding,
videos
ding,
are
ding,
composite,
knockout.
though,
Mic drop. Mic drop. Game over.
And where did that come from? What's
The
that
simple fact of the matter is, man, is that when you take a picture with a camera, any camera, it will create that file, that image file, and it will tell you the time and the date when the picture was taken, giving that the camera had the date and time set properly in the first place.
Well, if you zoom and of course, you can edit that information in Photoshop anyway too. You can edit the EXIF information.
Yeah, that's why it's not worth talking. That's why it's not worth
Riley's not prepared to do it yet. Yeah,
it's not prepared.
I'm not prepared to do it at all.
Not prepared.
Yeah, so I wouldn't give it to us yesterday.
I have to wait until he's prepared, and then
it's possible to edit metadata.
It doesn't prove anything.
It might take a
There is
while.
no value
You have
to it
to look at a lot
whatsoever.
of weather information.
EXIF data is not reliable unless you get it like quickly, right then and there when pictures taken and the files transferred.
And he wouldn't give it to us
People
yesterday.
can screw with that stuff.
That's weird.
Riley's just too slow and lazy to have done it already. Now that he's been, hemming and hawing and putting it off, we know what he's up to. So we know that whatever he does present is likely to be edited and false.
Speaking of hemming and hawing, did you hear him when he walked down that 20-meter little path to get the next bit of footage?
I didn't hear about it. I heard about it, but yeah.
It's in his original video. If you watch his original.
We get hammered with snow, and I had to walk 2 miles. Just before I got to my flat, I got a stitch. Oh, it's murder. Walking in the snow.
All things considered, Anthony Riley really is an expert on a tremendous number of subjects.
Yeah.
Are we talking about the point where there was 2 pictures? He'd taken 2 observations and said the same point, and then Jem's shown in his video how they're not the same point. You can see that. Is that what you're talking about, Lewis?
Ooh.
I'm talking everything that he says. He's clearly qualified to speak on.
I wonder what Riley thought about that in the video. And I've seen pictures as well with both your pictures overlaid, and you can see a different parallax of is it a buoy or something, or a buoy or whatever you call it on the horizon.
Yeah, I think it was a drilling platform. If I'm not mistaken.
Something like that. But
let's admit that footage is terrible, and it doesn't show.
There's only 60 seconds left, guys. There's only 60 seconds left.
That's what I say. So Riley, are you saying you really took those 2 from the same point?
I've been very clear in the description video, in the comments of Jeremy's comment. I stand by everything that's in there. All the points he's made in the video are addressed completely in there. I said in the video, I'll go and read the comments. I'm just gonna refer you back to the comments of Jeremy's video. Go and look at the comments. Go and read them for yourself, and I stand by what's been written in there.
Just say it. If you can't say it, do you see what a weasel you look like by not even answering it?
I don't care what you think of me. I really don't care. I've been clear with my position. I stand by my position. You can read it in the comments.
And with that, I will say, first and foremost, a huge, massive, enormous thank you to all of the live audience for tuning in and for sharing this debate. And also a massive thank you to all of the debating panel for making this debate possible. Be sure to like, comment, share, and subscribe. I've been Nathan Oakley, and I'll see you all in the next video.